Hello students, welcome to IMS Academy. Myself Jeprakash, lead mentor of EC branch at IMS Academy. In the last week, we started the Gate Score Booster session for digital circuit subject. We have done 2 live sessions. Whoever attended that live session, by this time you people might have checked your confidence regarding the particular subject. However, due to any reason, if you not attended live session or due to any reason if you missed for watching those lectures, kindly watch those lectures in your free time, whoever from EC, electrical, instrumentation, computer science. Okay, so in this particular session we are going to start the Gate Score Booster series regarding network theory subject. Today and tomorrow in these 2 sessions we are going to discuss the expected models or from the important and most important concepts of network theory subject. We are going to cover in the 2 sessions today and tomorrow. Okay, this subject is common for 3 branches: EC, electrical and instrumentation. Whoever from these branches and whoever going to write the GATE 2026 exam, by this time if you already thoroughly prepared, so with the help of whatever the questions we are going to cover in these 2 sessions, all of you can check your confidence and knowledge, whatever the preparation you have done, whether it is up to level or not, or whether you have to do further revision and practice, etc. You can check. Okay. Yeah. So whoever visiting our YouTube channel very first time, kindly subscribe our YouTube channel and then click on the bell icon so that you will be getting all the instant notification. So all of you can kindly like and share this video link with all of your friends so that they also will attend this session live and they also will get benefited from this particular session. Okay. So whoever not yet joined our Telegram channel, so the link is provided in the description of this particular video. You people can join in your free time. Okay, so all these important updates you are getting in our Telegram channel. Okay, yeah. So coming to the subject network theory, with respect to GATE exam point of view, we are having total 5 chapters. Okay, so in this particular session we are going to focus regarding first 3 chapters of network theory subject. Okay, in the first chapter you will be having like basic concepts like basic laws, basic methods, etc. and equivalent circuits, etc. we are having in the first chapter, whereas in second chapter theorems we are having. So broadly speaking, in the first and second chapter we will be focusing on DC circuits only. Okay, and in the third chapter we are focusing 2-port networks. And so regarding first 3 chapters, whatever the expected models from the important and most important concepts, so those questions we are going to cover in the span of 3 hours in today's session. Okay, and regarding the last 2 chapters questions we'll be focusing on tomorrow. Okay, we'll be discussing in detail on tomorrow. Okay, right. So here, like initially we are focusing the questions, as I mentioned, we will be focusing on 3 chapters like chapter 1, chapter 2 and chapter 3. Okay, so whoever already prepared this subject very well, by this time you people might have got to know, even the subject title is network theory, but most of the questions you have to solve. Circuits will be there, you have to find out voltage, current or power, etc. Okay, or equivalent resistance, equivalent inductance, equivalent capacitance, etc. Some quantity you have to find out. Okay, so when you are learning the subject, you will be learning method by method or concept by concept, etc. But after you thoroughly prepared first and second chapters, you will get to know that more than one method possible for most of the questions while solving. Okay, so that is the reason here we are focusing regarding first chapter and second chapter together. Of course, with respect to first chapter, whatever the questions flow wise will be there, I will be focusing. But when you are solving the question, if you want to solve with the help of first chapter concept, you can solve. Some questions there is a possibility even with the help of second chapter also you can solve that question. Okay, so that is the reason I am focusing here combinedly chapter 1 and chapter 2. We will be discussing all the variety of questions. After completion of these 2 chapters, we will be focusing on the third chapter, that is 2-port network. Okay, I hope all of you are eagerly waiting for the session. So let us start. Yeah, this is the first question. So here you are having one particular circuit diagram. Okay, so you are having 0.5 ohm here. In this branch the current flowing is given, that is 2 ampere. So here I value given as 2 ampere. Fine. What you have to find out? The value of V1 you have to find out. Here in this circuit you are having resistors. Okay, all the resistor value given. here supply voltage source is there. That voltage source value how to find out. The current flowing through this branch given. Yeah. So here if you observe, see, regarding network theory subject, generally many of the students may get the correct answer. There is no doubt. If you are strong in the basics, if you know the method of solving. But the most important thing regarding network theory subject, whenever you are having a circuit diagram, the starting point is most important. From where we have to start and which law or which theorem or which method we have to apply. So that observation points are important. Somehow other if you can figure out the starting point by which you can solve the question easily or you can solve the question in less time, definitely that approach is the best approach. But to get that one or to reach to that level, you should do good practice. Then only you can reach to that level. Yeah, you can cross check once your answer is not correct. Just give a try once again. Just mention your name also in the chart. Yeah, here the first and foremost observation, like just observe this point, one and the same, because between these 2 points we don't have any component, just one wire was there, right? So just for reference, suppose I'm labeling this node as like A, or suppose I'm numbering 1, okay, then this node I'm labeling as 2, then this node, all are one the same, number 2 only, and this node also same, number 2, and this node if you want you can give numbering as 3. So then you will get to know like which elements or which components or which branches are connected in series or parallel, etc. You can easily visualize. Now here if you observe, like in this branch 2 ampere current is flowing, okay, 2 ampere current is flowing. Now here if you observe, between points 3 and 2, here 1 ohm resistor is there. In this branch 1 ohm resistor is there, and one more path was there between 3 and 2, one more resistor, same value, 1 ohm. That means how these two are connected. These two are connected in parallel, right? These two are connected in parallel. Equivalent resistance what you are getting? 0.5 ohm. 0.5 ohm. Okay. Now between 1 and 2, you are having one voltage source. Between 1 and 2, you are having 1 ohm resistor. Okay. So you can easily understand from this diagram, but for better understanding, I will draw the equivalent circuit so that accordingly you can proceed further. So here we are having V1. V1 is there, then 1 ohm resistor is connected exactly in parallel to this particular branch. Okay, right. Next, you are having 0.5 ohm resistor here. Then here you got 0.5. Okay, right? So between 1 and 2, okay, just for reference, if you want, you can label the numbering later. Okay, so between 1 and 2, voltage source V1 is there. Between 1 and 2, 1 ohm resistor is there. Then between 1 and 3, 0.5 ohm is there. Between 3 and 2, 0.5 ohm is there. Okay, and in this question they have mentioned, that the current flowing through this branch is 2 ampere. 2 ampere is given. Now the same current 2 ampere is flowing here, right? That means these two elements or these two components are connected in series, right? 0.5 ohm, 0.5 ohm connected in series, equivalent resistance is 1 ohm. You can add right? Now just observe. Here you got equivalent resistance as 1 ohm. Through that 1 ohm, the current flowing is 2 ampere. By using Ohm's law, how much voltage you are getting? By using Ohm's law, how much voltage you are getting? 2 ampere into 1 ohm, that is 2 volt. 2 volt, right? That 2 volt, just observe here, between this terminal 1 and here the terminal is 2. Okay, this terminal earlier we have labeled as 3. Fine. So between 1 and 3, with the help of this branch, you got the voltage as 2 volt. Now between the nodes 1 and 2, you are having total 3 branches. Here voltage source, then 1 resistor, and then 1 more equivalent resistance. How these 3 elements are connected? How these 3 branches are connected? Parallel. In parallel, voltage will be same. That means here V1 equal to what? 2 volts. V1 equal to 2 volts. Yeah, many of you got 1 volt, but cross check, because of you might have done somewhere silly mistake or you might have misconception. So please cross check. Still, if you are having doubt, you can mention in the chart. Okay. So in this question, you are supposed to calculate V1. That V1 is 2 volt. That means option C is the correct answer. Option C is the correct answer. Yes, I hope it is clear for everyone. Right. Yeah, next question. Yashwant, is it clear? Any doubt? Previous question. In this question, just like earlier question, you have to find out the supply voltage. Yes. See here, this voltage source and 2 ohm resistor, how these two are connected? This voltage source and resistor, both are connected in series. In series, current will be same, right? In series, current will be same. So here in this particular circuit, the current direction is given like this and current value mentioned as I. That means the same current is flowing like this. Okay, just for representation, I'm just representing like this. So this is one of the important note point or observation point. Yeah, so just observe here. See, here you are having some like 3 branches are there. Whatever might be current distribution here. Overall, for this network, the current I is entering, the entire current should leave. Or in other words, these 2 elements current in series current will be same. So here, because current I is given, the same current is flowing like this. Yeah, definitely. We will be solving all the variety of questions. Currently, we are focusing first chapter, second chapter together. So all the basic laws, basic methods, whatever the theorems we are having, everything. We are having variety of questions in the flow. We will be covering. We will be discussing. No problem. You will be getting better understanding. Yeah, regarding that particular KVL in some time. Yeah. So this is the first observation point. Right. Now just observe. These 2 resistors are connected in parallel. These 2 resistors are connected in parallel, right? So equivalent resistance is how much? 1 ohm. Equivalent resistance is 1 ohm. Okay, now just observe. Here the current I is entering. See, to this particular node, current I is entering in this branch. In this branch, the current 0.5 I is entering. Right? That means together how much current is entering? 1.5 I. That entire 1.5 I should go in the equivalent 1 ohm resistor. I am repeating once again. See, here equivalent resistance you got 1 ohm. Okay. and here I is entering, 0.5 is entering, together 1.5 is entering, that 1.5 I should leave, that is leaving through 1 ohm resistor. Okay, 1.5 I is flowing through, 1.5 I is flowing through 1 ohm resistance. Very simple. What is KCL? Sum of entering currents should be equal to sum of leaving currents from a node. That's all. Okay. Now you can observe here current is entering, so plus here, minus here. By using Ohm's law, current into resistance is nothing but voltage, that is 1.5 I. Right. Now very simple. Here you are having one voltage source. Here you got voltage drop, and here also you can apply Ohm's law. Accordingly you are getting voltage 2 into I. 2 into I. Now just observe, here you got equivalent resistance 1 ohm. That 1 ohm resistance and this current source parallel, in parallel voltage will be same. So just you can apply KVL around this closed path. Just you can apply KVL around this closed path. Okay. Just apply KVL around this closed path. Now very simple, whenever you are having closed path, there you can apply KVL. Now with respect to every element, when you are having voltage polarities you are having plus minus. So you can consider clockwise or anti-clockwise, in any direction you can consider, no problem. And with respect to every branch, you can consider starting polarity or you can consider ending polarity. But in the entire closed path, you should have same convention. Say for example, for the time being, I am considering starting polarity, like here plus, then here also starting polarity plus, here starting polarity is plus. Okay. So here plus 2 minus, okay. For the time being, I am considering starting polarity. Okay. So you are getting plus V. Then here plus 2 minus, starting polarity is plus. Okay. 1.5 I. 1.5 I. And here starting polarity is plus 2I is equal to 0. See, this is one convention. This is one convention. With respect to every branch, you can consider starting polarity. Or if you want, you can consider with respect to every branch, second polarity. With respect to every branch, if you want second polarity, you can consider. Like here, second polarity is minus. Here, second polarity is what? Minus. Here, second polarity is what? Minus. Yeah. Here, plus 2 minus. Minus V. Minus V. Then plus 2 minus. Minus 1.5 I. Then plus 2 minus. Minus 2I is equal to 0. See, you can write like this or you can write like this. Both are one and the same only. 1 and 2 are same. How 1 and 2 are same? If you take from this whole equation minus as common, after that what you are getting? V plus 1.5 plus 2I is equal to 0. Both sides multiply with minus sign or minus 1. Then 0 into minus 1 is what? 0. Then here you got 0. Here all the terms become positive. I hope it is clear now. Regarding KVL, one student asked, right? I hope it is clear. See, with respect to in that closed path, for every element, you can consider starting polarity or you can consider ending polarity. But it's not that some elements you are considering starting polarity, some elements you are considering ending polarity. No, you should not. Every branch or every component, you have to consider starting polarity or you have to consider ending polarity. Okay. Now just rearrange. Very simple. So V, if you bring other side, it will become positive. Then these two terms you can add. You are getting resultant term is negative. 1.5 plus 2, that is 3.5 into I. So in this question, it is asked that voltage source value, you are getting negative minus 3.5 I. Minus 3.5 I, that means option C is the correct. Yes, I hope it is clear for everyone. Now the next question. Yeah, I am giving time. All of you can give a try. Yeah, just observe here. Like in this question, you have to find out voltage across 5 ohm resistor. Here in this question, 5 ohm resistor is present here, right? 5 ohm resistor between the terminals A and B. So across the with respect to the terminals A and B, 5 ohm resistor is there. Across 5 ohm resistor, you have to find out the voltage, right? Okay. Whatever the answer you are getting, you have to round off to the 2 decimal places. Okay, fine. Now, just by observation, here 2 ohm resistor and this current source and this 5 ohm, how these 3 elements are connected? How these 3 elements are connected? These 3 elements are connected in parallel, right? In parallel, voltage will be same. Okay. And here in this question, with respect to 2 ohm resistor, the voltage given as V1, the same voltage is present here, the same voltage is present here. Okay. So, as per the question, we have to find out across 5 ohm voltage, that is nothing but V1. Okay. Right. So, between the terminals A and B, see all these points are A, all these points are B, and in general, you can consider one of the node as a reference, okay, when you are solving the question by using nodal, right? Okay, so this node voltage with respect to ground is nothing but V1. If you calculate V1, that is the final answer, that's all. Okay, now we can solve this question by using nodal. Okay, so whenever you don't know current direction, you can assume that from that node current is leaving. Okay, so in this branch you can assume that current is leaving, here current is leaving, and here current is entering, you can consider accordingly. Here you can assume that current is leaving. See, all these points are one and the same. All these points are one and the same. Okay, fine. Now just write one nodal equation, that's all. Nodal equation is nothing but combination of KCL and Ohm's law together. Okay, so in this branch, see, very simple. Here 1 ohm resistor is there, one side voltage V1, other side voltage 5 volt. Just apply Ohm's law, that's all. The current flowing through 1 ohm resistor is V1 minus 5 divided by 1. V1 minus 5 divided by 1. Next, in this branch, current flowing is V1 by 2. V1 by 2. Now, here current is entering current is negative. Okay, here current source value is V1. Next, in this branch, current is leaving V1 by 5. V1 by 5 equal to 0. Right? Okay. Now just observe. You can do LCM or otherwise just by observation also. You can do some cancellation. After that further you can proceed. Like here plus V1 minus V1 will get cancelled. Right? And then here you are having minus 5, bring other side, it will become positive. And from here you can do the simplification. V1 if you take common, then you are having 1 by 2 plus 1 by 5 is equal to minus 5. If you bring other side, it will become positive. So you are getting 5. Now you can do the LCM. 2 5s are 10. So here 5 plus 2. Okay. V1 into this expression equal to 5. So from here you will be getting 7.14. After that you will be getting further digits and all. But when you do round off to 2 decimal places, then you will be getting final answer as 7.14. Answer for this question is 7.14. See, with the help of one nodal equation and one unknown voltage there, you can easily find out one unknown with the help of one nodal equation. Yeah, I hope it is clear for everyone. Now the next question. I am giving time for everyone. All of you can do it. All of you can give it a try. Yeah, in this question, you are supposed to find out the power delivered by 24 volt source. See, in this circuit, you are having voltage source 24 volt. Okay, and here current source is there, but that is a dependent source. Okay, fine. And then 6 ohm resistor is there. So in this question, with respect to 24 volt source, they are asking that how much power this source is delivering. Okay, see, whenever the context delivered, very simple, current has to leave from the positive terminal. If it is like that, then that element will deliver. Okay, but whether actually the particular element is delivering or not, ultimately after finding the, say for example here, voltage source value given, like as per the circuit current direction, if you are getting current value positive, that means here, like whatever the direction they have given, exactly same, that means current is leaving from positive terminal, that means that element is delivering the power. Say for example, with respect to 6 ohm resistor, whenever you are having resistor, inductor, capacitor, in general they are passive elements, they will absorb the power. Okay, but in the given circuit, when more than one source present, then all the sources may or may not. Okay, some of the sources can deliver the power, some of the sources can absorb the power. Okay, in some circuits, all the sources can deliver the power also, based on the other network elements connected and in which configuration they have connected also. Okay, now let us observe, very simple. Power basic formula is very simple, the product of voltage and current, that's all. Okay, power is nothing but voltage into current. Okay, now first of all you can write down, like with respect to 24 volt source, we have to find out the power, right? So power equal to voltage into current, voltage value 24 given, current value is I. That somehow or other, if you can get I value, that I value, whatever you are getting, that one you multiply with 24, that is the final answer. Okay, right. Right, because here current is leaving from positive terminal, that means this particular source will deliver. Okay, fine. Now just observe, 24 volt source, 6 ohm and this current source, how these three elements are connected. These three elements are connected in parallel. In parallel, voltage will be same. So here 24 volt is there. The same 24 volt across 6 ohm also present. Right? Okay. Now by using Ohm's law, voltage divided by resistance is nothing but current. So IR you are getting 24 by 6. That is nothing but 4 ampere. 4 ampere. Right. So in this particular example, the current flowing through 6 ohm is nothing but 4 ampere. Now, this current source value is nothing but 2 times IR. IR value is 4. That means 2 into 4 is nothing but 8 ampere. Right. Now just observe here to this particular node. If you observe here, current I is entering, and in this branch 4 ampere is leaving. Here in this branch 8 ampere is leaving. That means 4 ampere, 8 ampere together in these two branches the currents are leaving. Yes or no? So 4 plus 8 is nothing but 12. So that means here if 12 ampere is coming, then together 12 ampere can leave. Okay. See here, if 12 ampere is coming, then together 4 plus 8 is nothing but 12. That's all. Now in this particular example, I value become 12 ampere. So here 24 into 12. 24 into 12. So here you are getting 12 4s are 48. Then 12 2s are 24 plus 4, 28. 288 watt. 288 watt. So in this particular example, the current value become positive, and whatever the direction they have given, accordingly we no need to change. So since current is leaving from positive terminal, that element is delivering the power. So 288 watt, that is option D. Option D. Option D is the correct answer. So sometimes, as I mentioned, like when more than one source is present, then you have to identify like which elements are absorbing the power or which elements are delivering the power. Okay, now just for understanding point of view, let us continue further. Okay, with the help of this question, like here as per the question we got the answer, there is no doubt, but with the help of this circuit, let us try to understand here how much power you are getting, here how much power you are getting, and what kind of power it is, that also we'll see. Okay, fine. Now whatever data we got as of now, so according I'm mentioning, so here we got 4 ampere, IR value we got 4 ampere, right, and here 2 IR is nothing but 8 ampere, right. Okay, then 24 volts, 24 volt is the voltage across these two branches also, because all the branches connect in parallel. Now just observe. Here current is entering positive terminal. Current enters positive terminal. That means it is absorbing. So here in this case, 6 ohm resistor will absorb the power. See, in general, power formula is very simple, the product of voltage and current. But that particular power, whether it is absorbed power or delivered power, based on the sign convention. Okay, here current enters at positive terminal, that means it is absorbing. Okay, so here voltage value is 24, current value is 4. That means here you are getting 96 watt, right? Okay, so whatever the power here you got, that is the absorbed power. Just for reference, I am writing in short, absorbed power. Okay, now here just tell me whether this element is delivering the power or absorbing the power. This is very, very important. All of you can give it a try. Whether this element is delivering the power or absorbing the power. Yeah, just observe here, like current direction is downward. So here if you see, here if you represent that current direction, the current enters where? Positive terminal. Current enters positive terminal, just like here, current enters positive terminal, it is absorbing. Yes, exactly, this element is also absorbing the power. Yeah, so here with respect to 2 IR current source, the power voltage is same 24, and in this case current value is 8. Here you are getting 192, right? So this power also absorbed power only, absorbed power. Okay, now if you add these two, in this circuit total 3 elements are there, among which one element is delivering, other 2 elements are absorbing, right? Just add the powers here. 6 plus 2, 8, then 9 plus 9, 18, 1 plus 1, 2, 288 watt. So now just observe, whatever, when you're having overall circuit, whatever the net amount of power delivered, that should be absorbed by other elements. So in this question, only one element is delivering, that delivered power is 288 watt, that entire delivered power was absorbed by the other 2 elements together, right? So this is the total absorbed power. Okay, this is the total absorbed power. I hope it is clear for everyone. Just like KCL means what? You are having a particular node. To that node, how much total net current entered, that net same amount of current that should leave from that particular node. Similarly, KVL means what? You are considering one closed path. In that closed path, whatever the net supply voltage is there, that should be distributed across the other elements together. Similarly, regarding power distribution. Yeah, good evening, Suganya. So this is a very, very important concept regarding power delivered and power absorbed. Very simple. Regarding power absorbed, many of the students are very crystal clear regarding the passive element or regarding resistor. So regarding resistor, current enters positive terminal. If you are having the convention like that, that particular element will always absorb the power. If you are having exactly opposite means here in this particular example, current 12 ampere is leaving from positive terminal. Current 12 ampere is leaving from positive terminal, right? That means it is delivering the power. That's all. Okay. If you are having sign convention like this, that means that element will be delivering the power. In the question they ask delivered power only, that delivered power is positive. But intentionally some question they can ask with respect to the same source, they can ask that absorbed power. Then you have to put minus sign. That's all. Just like let us consider in this branch 12 ampere is flowing like this. In the opposite direction, how much current is flowing? Minus 12. So when you're considering minus 12, that minus 12 ampere actually entering positive. So because current enters positive, it is absorbing. So accordingly, absorbed power you are getting negative. That's all. Okay. Similarly, whenever you are having passive element, by default you are getting absorbed power. But intentionally, if they ask you to calculate delivered power, whatever the absorbed power you are getting, for that you have to put minus sign. That's all. That is the delivered power. Because actually the element is absorbing, but because they asked the delivered power by this element, then the delivered power will be negative. Okay. Yeah. Now the next question. Yeah, very interesting question. I'm giving 1 minute time. All of you can give it a try. Many of the students may solve this question wrongly. There are high chances many of the students may solve the question wrongly. See, even the question, matlab, you can easily solve, but many of the students might be having misconceptions or might assumed, matlab, might have undergone some traps. Okay. So what are the questions we are covering in this session and of course in tomorrow's session also regarding network theory subject? We are discussing all the important concepts and most important concepts related questions and even variety of questions, and not but not the least, in general, wherever majority of the students may do silly mistake. Those areas also we are covering so that you people can overcome that kind of challenges or mistakes actually in your actual GATE exam. Okay, right. So first and foremost, just observe, as per the question data, you have to find out equivalent resistance between the terminals A and B. Okay, here terminal A is there, here terminal B is there. With respect to these two terminals, you have to find out the equivalent resistance. Okay, fine. Equivalent resistance you have to find out. Yeah, Suganya, it is not correct. You will be getting integer number only, integer. Okay. Yeah. So between the terminals A and B, you have to find out the equivalent resistance, right? Okay. Now just observe, here terminal A, here terminal B. Okay, just by observation, sometimes whenever you are having configurations like this, sometimes few students may apply like star to delta, delta to star, etc, 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 whatever other methods are there. Okay, but just have a close observation. If really required, you can apply. Okay, if there is no other possibilities, if that is the only method, then you can apply wherever there is a requirement. But without just by observing, like wherever series connections or parallel connections are there, with the help of that, if there is a possibility to do the simplification, first do it. Okay, and just observe here, like this point, this point, this point, all are one the same. That means for the time being, I am labeling the same node B. Same node B. Okay, next, here you are having one more node. For the time being, I am labeling as C. Okay, so just for your information, this point also same B only. Correct? Now, apart from that, any other nodes are there? In this circuit, three principal nodes are there. Yes or no? A, B already given. So one more node, that is C. That's all. Here, all these nodes are one the same. Okay. Now just observe. Between C and B, 12 ohm resistor is there. And between C and B only, 12 ohm resistor is there. Correct? That means these two are connected in parallel. So equivalent resistance you will be getting 6 ohm. Between C and B, because of these two resistors are connected in parallel, equivalent resistance you are getting 6 ohm. Fine. Now the most interesting thing and important thing is here, where in general students will do mistake here. Okay, majority of the students might have considered that up here there won't be any silly mistake. Many of the students might have solved correctly. Many of the students might have considered here equivalent resistance here 24 ohm, but here only mistake is there. Just observe here. Between B and B. Okay, between these two nodes, you are having 24 ohm. Between these two nodes, you are having 0 ohm. You are having one wire. One wire means it is 0 ohm. Ideal wire. Internal resistance is 0. Now, between these 2 points, 2 resistors are there. Just like between these 2 points, 2 resistors are there. Like that you can treat, or otherwise, because end points are same, directly also you can say. Or if you don't know, like if these 2 points are one the same or not, when you not noticed, that time at least, just like here, 2 different nodes when you considered, after that, here you observe that between those 2 nodes, these 2 resistors are parallel. Exactly in similar way, between these 2 points, here one branch is there, resistance is 0. Here another branch is there, resistor is 24. These 2 branches are connected in parallel. So equivalent resistance, how much you are getting? 0 ohm. See, what is the equivalent resistance? R1, R2 by R1 plus R2. 0 into 24 divided by 0 plus 24. That means you are getting 0 ohm. Okay, that means here what is your observation? Okay, I am drawing the equivalent circuit here. So here between A and C, we are having 8 ohm. Fine. Next, between C and B, we got here 6 ohm. Between C and B, we got 6 ohm. Right. And then here between C and B, 12 ohm is there. Between C and B, 12 ohm is there. Okay. See, as of now, I consider this branch 8 ohm. And then I considered here equivalent resistance 6 ohm. And then here 0 ohm. Just observe here. Between these 2 points, we got 6 ohm. Between these 2 points, we got 0 ohm. Okay, just for reference, I am mentioning here. Yes, here you got 0 ohm. Okay, next, between A and B, we are having 12 ohm. Between A and B, we are having 12. Yeah, between A and B, we are having 12. Now just observe how these two branches are connected. In series, we can add the resistances. So equivalent resistance, how much you are getting? 6 ohm and then 0 ohm. Okay, just for reference, I am putting this node same, C. So 6 plus 0 is nothing but what? 6 ohm. 6 ohm. Now just observe, between C and B, 12 ohm was there, and between C and B, in another branch, you got 6 ohm. Now 6 ohm and 12 ohm are connected in parallel, right? So here 12 in parallel with 6. 12 into 6 divided by 12 plus 6. Okay, so 12 into 6 divided by 18. So 6 3 times, 3 4 times. Okay, that means this entire branch between C and B, we got equivalent resistance as 4 ohm. Now, whatever this equivalent resistance you got 4 ohm, that 4 ohm and 8 ohm, how they are connected? Series. Okay. Yeah, just for reference. Yeah, I will be drawing the next slide. Okay, or otherwise I will draw here only. Very simple. Here we got 8 ohm already between the points A and then C. Now between points C and B, just now we got 4 ohm. And between A and B, one more branch was there, that is 12 ohm. That is 12. So in the question they asked between terminals A and B. So with respect to terminals A and B only, you have to find out the equivalent resistance. Okay. Now here if you observe, 8 and 4 are connected in series. That means 12 ohm you are getting. And here 12 ohm and 12 ohm, how they are connected? Parallel, right? So that means from here you are getting RAB is nothing but 12 parallel with 12. 12 parallel with 12. That means 6 ohm. 6 ohm. The final answer for this question is 6 ohm. In general, many of the students will do silly mistake here. Because of that, they will be getting wrong answer for this question. But no issue. Whoever got wrong answer while solving this question, either in live class, live session, or might be watching in the recorded, no issue at all. Because the session purpose is, as I mentioned earlier, we are touching, with the help of these sessions, we are covering in general wherever many of the students may do silly mistake, we are covering those areas also, so that you people can overcome in the actual GATE exam. That is our motto. Suganya, is it clear now? I hope many of the students felt this is one of the interesting question. Even though question solving wise easy, but there are high chances are there, many of the students may do somewhere while solving the question silly mistake. There are high chances, because of that they may get wrong answer. Okay. Yes, I hope it is clear for everyone. Yeah. Next question. I hope this question everyone can solve correctly. I am giving time for everyone. Try your level best. Yeah, Suganya, cross check once again. Yeah, if you mention for previous question, that means your answer is correct. But if you mention for this question, no, just cross check. Here answer will be in the order of kilo. Yeah. So just like earlier question, here with respect to the terminal C and B, between the terminal C and B, we have to find out the equivalent distance. Equivalent distance we have to find out here. Okay. Now just observe. Here 24K and 8K, these two are contained parallel. Because we have understood very well with the help of earlier questions, series connection, parallel connection. So I am not discussing once again that much detail. But if at all, if any of you are having slight confusion or doubt, so just put the lettering or numbering for the notes. From there, you will get to know like which elements or which branches are contained parallel or which branches are contained series. Okay. So here 24 and 8 are contained parallel. So here you are getting, I'm writing here 24K into 8K divided by sum of these two, that is 32K. R1 R2 by R1 plus R2, right? So here 8K 4 times, now 4 here 6 times, that means you are getting 6 kilo ohm. So here after doing the simplification here, right, equivalent resistance, one resistor you got, that is 6K. Fine. Now that 6K and 8K, how they are connected? Series. So 8K and 6K are connected in series. So we can add the resistances. 14 kilo ohm we are getting. Fine. Up to here we got 14K. Now that 14K and 14K connected in parallel. 14K connected in parallel with 14K. So here equivalent resistance you are getting 7K. 7K. Fine. No, Suganya, still you are getting wrong answer. Okay, no problem. You can cross check here. Okay. So here 14K, 14K, content parallel, 7K we got. See, once again I am repeating, up to here equivalent resistance is 6K, that 6K and 8K content series, equivalent resistance is 14K, 14K content parallel, equivalent resistance is 7K. Now, up to here we got 7K. Now that 7K and 3K connected in series. So 3K and 7K are connected in series. Equivalent resistance you are getting 10K. 10 kilo. Fine. I hope it is clear up to this point. Very simple. Between this point and this point, whatever this entire circuit was there, this entire equivalent resistance is nothing but 10K. Fine. Now here if you observe, 20K, 10K and whatever this entire equivalent resistance 10K you are getting, these three branches are contained parallel. So now equivalent resistance what you are getting, 20K parallel with 10K, 20K parallel with 10K, parallel with 10K. So here you can do equivalent resistance easily. Okay, you can start from here also, but because equal resistances are there, from there you can find out equivalent resistance easily. Okay, 10K parallel with 10K is nothing but what? 5K. So here you are getting 20K parallel with 5K. Now you can find out 20K into 5K divided by sum of these two, that is 25K, right? So if you do calculation part, so here 5K 5 times, then 5 4 times. That means you are getting 4K. 4K. Now what you got between these 2 points, whatever the resistive network is there, the entire resistive network equivalent resistance we are getting 4K. Right? Now that 4 kilo ohm, that entire equivalent resistance 4 kilo ohm is in series with 6K. Right? Yeah. So now the final answer you are getting RAB or R equivalent, whatever they mentioned, that is 4 here 6K in series with 4K. That means it is 10 kilo ohm. 10 kilo ohm. So here already the order of units kilo ohm mentioned. So accordingly the answer for this question is 10. Suppose in the question if they mentioned only the units as ohm, that means that time you have to mention 10,000. So the order of like whenever you are solving any NIT question, if that quantity is having units, and the order of units is very important, not only in this subject, in any subject, any technical subject or non-technical also, wherever like any parameter, if it is having order of units, just make sure in which order of units they're expecting. See, in this question they're expecting the order of kilo ohm, that's why answer is 10. But if they expect in the order of ohm, for this question answer will be 10,000. Of course, for NIT there is no native marking, but when they're asking in the order of ohm, but that time if you mention 10, your answer is not correct, because when they're expecting order of ohm, answer will be what? 10,000. But when they're expecting the order of kilo ohm, answer is 10. So this precaution or this very important point you people can make a note, because whenever you're solving the question, damn sure you'll be happy. Okay, but and at the same time you'll be in hurry in the exam. So the moment you're getting answer, you won't focus whatever the main key points or keywords are there. In hurry you may mention something. After seeing the answer key, most of the time you may feel disappointed because you haven't taken care of whatever the main important note points are there. Okay, so this is a very important note point. Yes, very good, Suganya, very good. Now the next question. Yeah, I am giving time for everyone. All of you can do it. Okay, I am given 2 minutes time. Give it a try. Yeah, some students already tried this question, but whether your answer is correct or not, I'm keeping some suspense. Okay. Yeah, just observe here. See, whenever you're having some equivalent circuits like this, thus many of the students will face the difficulty in order to identify like which elements or which branches are contained series or which branches or elements are contained parallel. So very simple, whenever you are getting like that confusion or dilemma, just put the labeling with the alphabets or with the numbering based on your convenience. Say for example, in this question they have given alphabets, right? A, B, C, D. So accordingly just observe, like here this point here in this circuit, like whatever this point was there, so this point is same. What is that point? B. This is the first and foremost observation. We already covered in this manner earlier some questions, right? Yeah. So here all these points are one the same, that is B. Now just observe here, as per the context, equivalent resistance we have to find out with respect to terminals A and B, correct? So here between the terminals A and B, we have to find out the equivalent resistance, RAB or R equivalent, whatever. Fine. Now here between A and B, we have to find out the equivalent resistance, and we observed that all these points are one the same, right? Okay. Now just observe between point C and B, here 10 ohm resistor was there, and here one more path was there, between C and B, 10 ohm resistor is there. See, this is the important key point. Okay, between C and B, here you are having 10 ohm, and here also one more 10 ohm was there. How those two are connected? Parallel, right? And similarly, between D and B, here we are having 10 ohm, and between D and B, we are having 10 ohm. So that means these two are connected in parallel, right? So this is the first and foremost observation. So very simple, like here between D and B, 10 ohm parallel, right? Between D and B or B and D, in any order you can write, no problem. B and D or D and B. Anyway, that is equivalent resistance, no problem. In any order you can write. RDB or RBD. In any order you can write. So 10 parallel with 10. 10 ohm parallel with 10 ohm. That is 5 ohm. Similarly, between points C and B or B and C, once again 10 parallel with 10, that is 5 ohm. 5 ohm, right? Up to here, if you got correct, after that you can easily solve further. Okay. Now, whatever the part of the circuit you got, now you can draw the circuit. Like here I am considering one point B. Okay. From that point B to the point D. From the point B to the point D, we got one equivalent resistance. That is 5 ohm. And similarly, between the point B to another point C, we got same equivalent resistance 5 ohm. Correct? Now, whatever the rest part of the circuit you are having, that you can continue. Here, as per the given circuit, you are having here between D and A. And similarly between C and A. Right. Between points D and A, we are having 5 ohm. And similarly, between points C and A, we are having 5 ohm. Right? So, as per the question context, between A and B, we have to find out. Between A and B or B and A, equivalent resistance same. Because ultimately, you are getting resistance only, right? If it is a voltage or current, etc., based on, like the moment if you are changing the terminal order, then polarity may change or direction. Because of the direction of current, then according to value, polarity, if you are getting positive, that will become negative in another context. But coming to the equivalent resistance, between A and B or between B and A, that is one and the same. Okay, fine. Now here what you are getting? 5 ohm, how these two are connected? Series. 5 ohm are connected in series. Here equivalent resistance is how much? 10 ohm. And similarly here 5 and 5 are connected in series, equivalent resistance is 10 ohm. Now between points B and A or A and B, two equal resistors are there, 10 ohm. What is the equivalent resistance? Suganya, now give it a try. So here equivalent resistance RBA or RAB, one and the same. What is that one? 10 ohm in parallel with 10 ohm. Already we solved, that is the equivalent resistance as 5 ohm. Okay, answer for this question is 5 ohm, that is there in option C. Option C. No issue, some students are getting wrong answers, don't hesitate, because in general in the network theory subject many of the students may know the basics but not up to level. Okay, or sometime there are high chances so many students will do some assumptions and all, but the most important thing, whatever the basics are there, whatever the concepts are there, you have to apply carefully. Then with the help of this series, at least today's session and tomorrow's session, with the help of 6 hour sessions together regarding network theory subject, whatever mistakes you people can do as many mistakes while you're solving very first time, but after, for every question when I'm disclosing the explanation or when I'm discussing the solution part, with the help of that you can make a note whatever the mistakes you have done and because of what factors, or silly mistake or calculation mistake, etc. Just make a note. Definitely that is a great learning, I can say, because if any student, especially when preparing for GATE exam or any other competitive exam, if any student not doing even single silly mistake while doing the preparation, then there are high chances he may get in the actual GATE exam, he may do more mistakes. But whoever done decently good number of mistakes, even more mistakes also while they are doing preparation, but from every mistake, if you learn something either with respect to concept or with respect to calculation part or whatever, etc., whatever the learning is there with the help of that question or solution, if you got updated, that is a great learning. Because let us assume that in one subject you have done 100 mistakes, but all the mistakes should not be same, right? 100 different mistakes if you have done, example, then definitely whatever the learning that you have gained with the help of those mistakes, it has made your understanding or concept, like whatever the knowledge, it is to the higher level. Okay, when you have done that many mistakes, and since you have got great opportunity to learn and update yourself regarding that particular subject, damn sure you can perform well in the actual GATE exam, or not only GATE, any other competitive exam whichever you are attempting. Okay, yeah, so the final answer for this question is option C, right? Always in my regular class, of course, even YouTube session also, whenever I'm taking any session, in general, I always will tell my student, I always will give the environment in such a manner for the students, let them do mistakes, as many new mistakes as possible. Okay, but don't repeat the same mistake. If you are repeating same mistake, that means you are not learning anything from there. Okay, but if you do different mistake, then from every new mistake you are learning something, then definitely you have learned greater extent. So that knowledge, that is the actually real way of to learn and understanding any subject. But let us consider in one subject you might have reached thoroughly without doing silly mistake, but there are some concepts or topics are there where you might be having chances doing silly mistake. But don't hesitate, let the mistake you can do while you are doing preparation. But I am not telling that you have to do mistake in the actual exam. Okay, but as many new mistake possible before the GATE exam only you can do, so that from every mistake you are getting greater greater opportunity to update yourself. Okay, right, yeah. Next question, all of you can read the question once. Okay, I'm just giving 1 minute time only, just give it. Yeah, let us read the question. So in this question, you are having one particular network which consists of large number of ideal linear resistors, one of which they have considered one resistor, resistance values R. Okay, and two constant ideal sources. Okay, you are having one particular network where multiple resistors are present, among which one resistor they have considered R, and two sources are present in that overall network or circuit. Okay, now what they mentioned, the power consumed by that resistor is P1 when only the first source is active. Okay, and similarly the power is P2, power consumed by the same resistor is P2 when only the second source is active. Okay, now the question is, if both the sources are active, then simultaneously, then the power consumed by resistor R is. In general, many of the students, while solving this question, they will apply superposition theorem. Whatever, like in case 1, the current I1 you got, case 2, I2. So by using that particular principle, many of the students may answer this question, like since we know that I equal to I1 plus or minus I2, or V equal to V1 plus or minus V2, like that P equal to P1 plus or minus P2. Some students may choose option A, but option A is not correct. Yes, very good, Suganya. Very good, excellent. So for this question, very simple, when you're having one resistor, okay. So in general, the basic formula is power equal to V into I, but after that V equal to IR when you have used, from there you are getting resultant further derived formula. You can use I square R or V square by R, any formula you can use. For the timing, I'm using power equal to I square R. Okay. Now, with respect to case 1, power is what? P1, then current will be I1. So just rearrange from this equation. You are getting I1 square equal to P1 by R. After that, you can perform square root on both sides. From there, you are getting under root P1 by R. Yeah, under root P1 by R. Fine. Now, in case 2, P2 equal to I2 square into R. Now, from here, you are getting I2 equal to under root P2 by R. See, whenever you are having one resistor or any element, with respect to, like when you consider one source, because of that source you can calculate current. Similarly, because of other source you can calculate the current. Then after that, with the help of superposition theorem, you can perform algebraic sum. Okay, by using superposition theorem, you are getting the resultant current that is flowing through the same resistor when both the sources are present actively, okay, at the same time. Now, I equal to, if the current directions are same, we can add. If the current directions are opposite, we can subtract. Okay, since we don't know here, we can consider generalized case. I1 plus or minus I2. I1 plus or minus I2. So from here, what you are getting? Root P1 by R plus or minus root P2 by R. Right? So from here, if you observe, denominator you are having root R, you can take common in the denominator part. So accordingly you can represent. And numerator you can keep root P1 plus or minus root P2. Fine. Now you have to calculate power across the same resistor. Now power equal to, you know the formula, I square R. Power equal to I square R. Now, here in place of I, this entire expression you can substitute. Okay, this entire expression you can substitute. Then what you are getting? Whole term square multiply with R. Okay, numerator part as it is, root P1 plus or minus root P2. And denominator you are having root R. Okay, root R whole square is nothing but R. R and R will get cancelled. Okay, so from here you are getting root P1 plus or minus root P2 whole square. Yes, that is there in option C. Under root P1 plus or minus under root P2 whole square. Yeah, final answer for this question is option C. Option C. See, with respect to voltage, you can write like V1 plus V2 or V1 minus V2. And similarly, with respect to current, I1 plus I2 or I1 minus I2, you can write. But exactly in a similar way, why we should not write P equal to P1 plus V2 or P1 minus P2? The reason is when you write V equal to I into R, V is the first order, I is also first order, right? So it is a linear relation. Okay, and here if you observe, anyway, R is the constant. But here just observe power, you are getting what? Here square of the current. Similarly, when you write V square by R, that square you are getting power other than 1 when you are having, okay, then it is the non-linear quantity. That is the reason we cannot apply superposition theorem for non-linear quantities or non-linear circuit. Okay, but we can apply for linear circuit, linear quantities. Okay, this is a very, very important note point. Yes, next question. So up to here, if you observe, up to before this question, most of the questions whatever we have covered till now, like till 7th question regarding first chapter. Okay, and with the help of this question, we have introduced the superposition theorem. Okay, now currently we are discussing concepts or questions regarding second chapter. Of course, while solving this one, whatever first chapter concepts or methods required, that also will apply. In this question, you have to find out VTH and RTH both. Okay, regarding VTH 2 choices, regarding RTH 2 choices. Now, before solving this question, one interesting question I have mentioned here. In order to find out VTH, for this particular circuit, how many methods possible? You can consider first chapter concepts, second chapter concepts. Together, how many methods possible for finding VTH for this particular circuit? Just try to recall whichever methods or concepts that we can apply for this particular circuit in order to find out VTH. And whether your answer is correct or not, I will keep suspense, and we will be discussing whatever the possible methods are there for finding VTH one by one. Okay, and after some time, like you will come to know total how many methods possible for this particular circuit. And if at all, if you get what are the methods we are covering here based on the possibility, even after going through all the methods, still if you feel, sir, we can solve this question one more method or other possible methods also, no problem. Whoever attending live, they can mention the further methods in the live chat only, and whoever watching this session recorded, you people can mention the comment section. Just mention the question number and mention the method name or concept name with the help of which we can solve the same question for finding VTH. If that method is possible for this question, definitely I will appreciate in the comment section. Okay. Yes. Yeah, any guess how many methods possible? Yeah, you people can contemplate. Okay, but even the question here, according to the question context, this question belongs to second chapter only. There is no doubt. You have to find out VTH, you have to find out RTH. Okay, regarding R equivalent, we solved good number of questions, but with the help of this question, you are getting whatever other possible cases are there with the help of this theorem, that also you are getting to know in some time. Okay, coming to the, like with respect to Thevenin's theorem or Norton's theorem, like calculation of VTH or calculation of short circuit current, regarding that we don't have any discrimination. All the circuits you can consider like one and the same. Like with respect to first chapter or second chapter, whichever concept or whichever method you are comfortable, according you can give a try. For the circuit, whichever method possible also. Okay, now just observe regarding VTH. VTH means what? Very simple. Like here with respect to terminals A and B, you have to find out VTH. VTH is nothing but Thevenin's voltage or open circuit voltage. In many of the questions, they will keep terminals open only. But whenever, if they have given some load, then that load you have to remove, terminals become open. Across the open circuit terminals, you have to find out the voltage. That's all. Okay. Now, first method is with the help of first chapter, basic laws, KCL and KVL. With the help of that, we solved good number of questions also in this session. Now, once again, we are applying here. Some students might be thinking, sir, how it is possible for solving this question with the help of KCL, KVL? Just have an observation. So here between the terminals A and B, you have to find out the voltage. That is your VTH, right? So here open circuit voltage, that means no current flows here. If no current flows here, then how these two elements connected? These two elements are connected in series. Okay, those two elements are connected in series. In series, same current will flow. Okay, equivalent resistance here in this case, that is 10 mho. Equivalent resistance is 10. Okay, in series, same current will flow because here no current flows. Okay, right. So just observe here. Let us assume that the current flowing here, it is I, suppose. Okay, here in this branch current I is entering, here already 6 ampere is entering. Together how much current will flow? I plus 6. I plus 6 just by applying KCL. I is entering, 6 ampere is entering. Together I plus 6 should be. Because these two elements current is series, whatever the current is flowing here, same current, that's all. Okay, now here just if you observe, you got one equivalent resistance 10 ohm. Okay, you got one equivalent resistance 10 ohm, right? And that 10 ohm and this 6 ampere connected in parallel, in parallel voltage will be same. Okay, now so by using this current and this resistor, you will be getting voltage here. You will be getting voltage here. Here 10 into I plus 6. 10 into I plus 6. This is the voltage between this point and this point with the help of this equivalent resistance you got. Right. Now, here also you can apply Ohm's law. So here you are getting 6I. Now just apply KVL. That's all. Okay, we have used KCL, and in order to find out the voltage, we have used Ohm's law, and now you can apply KVL. Okay, you can apply KVL like this, or clockwise, anti-clockwise, your wish. Now here minus to plus, plus 12, then plus 2 minus, minus 6I, then plus 2 minus, minus 10 into I plus 6 is equal to 0, is equal to 0. Minus 2 plus, plus, plus 2 minus, minus, plus 2 minus, minus. Okay, now just do the simplification. So here what you are getting, 12 as it is, then minus 6I, here minus 10I you are getting, direct step I am writing 16I. Okay, 6 plus 10 is 16, then minus 60 you are getting. Minus 60 you are getting. Okay, now from here, if you bring this minus 16I to other side, it will become positive. From here you are getting 16I is equal to 16I is equal to 12 minus 60, that is minus 48. Right. So that means here 16 3 times. I value you are getting negative, minus 3 ampere. I value you are getting minus 3 ampere. What is our objective? We have to find out VTH. VTH is nothing but between the terminals A and B. Between the terminals A and B, 4 ohm is there. 4 ohm resistor, and current you know. Current is how much? I plus 6. Right. So here VTH is nothing but across 4 ohm voltage, just for reference. Like here 4 ohm resistor is the resistance, and current flowing in this branch is I plus 6. I plus 6. So I value just now we got minus 3 plus 6. 6 minus 3 is 3. 4 3s are 12. Right. Thevenin's voltage is 12 volt. Thevenin's voltage is 12 volt. That means option B. Actually, this question is MSQ. Right. You have, right, 2 options you are having regarding VTH, 2 options you are having RTH. Okay, regarding RTH we will be discussing in some time. Currently we are focusing regarding VTH calculation. So among A and B, option B is the correct one. Suganya, is it clear? Any doubt regarding VTH with the help of KCL and KVL? Yes, I hope it is clear. Now we are going to solve this question by using nodal. See, all the possible methods or concepts that you have learned with the help of first chapter and second chapter, we are going to apply here. See, that is the beauty of our subject. That is the beauty of our subject, network theory. You no need to solve n number of different questions. Question is one or circuit is one. With the help of that, whatever possible methods or concepts you can apply, that in that approach, if you learn or if you solve, that learning is a greater, I can say, greatest. Okay. Yeah. For practice and for getting deeper insights. Okay. So whatever possible methods are there, I'm covering here. But if you feel further more methods possible, sir, for the same question, you people can mention in the live chat, whoever attending currently or whoever watching this session recorded, you people can mention in the comment section. Okay. Yeah. So now we are going to solve by using nodal. Yeah. So here, this node we will consider the reference or ground, bottom node. Okay. Then here, this node with respect to ground, you can assume like V1. Okay. Now here, you have to find out voltage across these two terminals, that is your VTH. And here, just like earlier I told, no current flows in this particular branch, right? If no current flows, that means these two are connected in series, whatever we discussed earlier, exactly same. 6 and 4 connected in series, that means 10 more, right? Okay. Now, you can assume that current is leaving. Whenever current direction not given, you can assume that current is leaving from that node while you are doing the nodal analysis. And here, current direction given. Here, you can assume that current is leaving. And here also you can assume that current is leaving. Yeah. So just write one nodal equation. Write one nodal equation. Here in this branch, current flowing is V1 minus 12 divided by 6. Right. Here current is entering current is negative. Leaving currents are positive, entering currents are negative. Okay. If you want, you can consider exactly opposite also, no problem. Okay. V1 minus 12 by 6. Here 6 ampere is entering negative. Here in this branch, leaving current V1 by 10 is equal to 0, right? So you can do further simplification like V1 by 6, then minus 12 divided by 6, that is minus 2, then minus 6, then V1 by 10 is equal to 0. Okay, you can take V1 as common from first and last. See, solving wise, whatever methods you are good at with the maths account, you can follow. Okay. For the timing, I might be discussing different approaches. Whichever method you are comfortable, account you can do. Okay, you can follow regarding simplification, no problem. Like from first and last, I am taking V1 common, then you are having 1 by 6 plus 1 by 10. Next, minus 2 minus 6, that together you are getting minus 8. If you bring to the other side, it will become positive. Okay, regarding 6 and 10, LCM, how much you are getting? 2 3s are 6, 2 5s are 10. So, you are getting 30. Here 30 is the LCM. So, 5 6 are 30, then 10 3s are 30. So, from here you are getting 8 by 30, V1 into 8 by 30 is equal to 8. Here 8 is getting cancelled. So from here you are getting V1 value is 30 volt. V1 value you are getting 30 volt. Okay. But what we require, we have to find out VTH. Yes, Suganya, very simple. Just observe here. Just observe to this particular principal node. For this principal node, this is one branch, the second branch, and this is a third branch. 3 branches are connected because in this branch no current. When no current flows in this branch, then whatever the current is flowing here, the same current is flowing. Because if you apply KCL here no current flows. That means let us consider current I1 is entering, the same current I1 is flowing. That means here when you observe that these two elements are connected in series, equivalent resistance how much? 10 only, right? And like here you are having one equivalent resistance 10 ohm. With respect to the 10 ohm, bottom node voltage 0 and here node voltage V1. Just you apply Ohm's law. That's all. V1 by 10. Simple logic. You are having one resistor 10 ohm. Here node voltage V1, here node voltage 0. V1 minus 0 divided by 10. That is nothing but V1 by 10. Okay, I hope it is clear. Yes. Okay, now you got V1 value as 30 volt. Right. Now, what is our objective? Just observe. Forget about this entire part, whatever you got. Very simple. Now, 6 ohm, 4 ohm and whatever 30 volt you got. Now, all these three elements, how they are connected? Series. In series, current will be same. Voltage is getting distributed. Now, you can apply voltage division rule. So, VTH, VTH you can get by applying voltage division rule. Here supply voltage is V1 into across which branch you want the voltage, that branch resistance will come as the numerator. So here numerator is 4, denominator is sum of the resistors, 6 plus 4. Here V1 just now you got 30, then numerator is 4, denominator is 10. So here 1 0 is getting cancelled, 3 4s are 12 volt. Yes, exactly same answer whatever you got earlier, whatever we got earlier, right? Option B is the correct answer. Yes. See, here for understanding purpose, we are using voltage division rule. See, the beauty of this subject is, whenever some concepts or formulas are there, if your basics wise crystal clear, if you are good at aptitude, with the help of that logic also you can solve. And or in other words, if you are good at network theory subject, with the help of this, you can solve some of the questions of G also. Okay, how it is? Very simple. Like just have observation. Like here 6 plus 4, together 10 ohms resistor is there. You are having 10 ohm resistor. Across 10 ohm resistor, you are having supply voltage how much? 30 volt. Now that 10 ohm just represent like 1 ohm resistors, 10 you keep in series. Very simple, right? Here equivalent resistance how much? 10 ohm, right? So I connected 1 ohm resistors 10 in series. That means equivalent resistance how much? 10 ohm only. That means across that entire 10 ohm, I am having supply voltage 30 volt. Now, whoever good at logic or aptitude, just give the answer. Across 1 ohm resistor, how much voltage you are getting? Overall, like 10 ohm equivalent resistance, you are having supply voltage 30. Now my question is, across each 1 ohm resistor, how much voltage you are getting? Very simple. 30 divided by, here 10 ohm is there. Across 1 ohm, you are getting 3 volts. That's all. Like that, here you want across 4 ohm. That means 1 ohm resistors, if you are considering 4, that means across that voltage. That's all. That means across 1 ohm resistor, you are getting 3 volt. Like that, you have to consider 4 times, right? So 4 into 3 is nothing but 12. That's all. I hope all of you understood that logic. This is very, very important. See, regarding network theory subject, most of the gate questions, if you observe, calculation wise, they never ever give intentionally more, the calculation part, it is taking more time. Whatever the component values they are making in such a manner, calculation part they will keep easy only, and many of the times you can solve with the help of, if you are good at maths or aptitude, solving part. But the most important thing with the help of this subject is which method or which law or which concept, with the help of that you can easily solve that question and in less time. That is the art that they want to check while you are solving the gate questions regarding network theory subject. Of course, there may be some questions, not only this subject, any subject, calculation part also may take relatively more time. That is there. I am not talking about that. But in general, whenever you want to learn any subject, focus on the concept first. Okay, solving part, at least with the help of maths or GA, somehow that if you are good at solving part easily, or if you don't know, at least with the help of that subject, try to learn whatever the techniques and tricks are required in order to solve the question in less time. So like that, with the help of one subject, when you learn something, you try to apply that same thing if really required in another subject while solving. In that manner, cumulatively you can perform well in the competitive exams like GATE. In the less time, you can perform optimizedly, and accordingly you can get whatever the best marks you can get. Otherwise, many of the students may feel that sir, time was not sufficient. Time is same time 3 hours for topper also and for weaker student also. But how effectively you are utilizing, that is there in your hand. But to make sure effectively to utilize, you should do good practice. With the help of that, you can get the ideas and all. Definitely you can effectively utilize actual GATE exam time. Okay. Yeah. So far we have discussed two methods. First one is KCL, KVL. Second method is nodal analysis. Now we can solve this question by using mesh analysis. That means here with the help of mesh analysis, okay, if you want to solve, like here two closed paths are there, right? This one closed path, right? So this is one mesh. Okay, I mean to say with respect to meshes I'm talking. So here you can consider mesh current I1. Here you can consider mesh current I2. Anyway, it is a open part, so you can ignore this part. Okay. Here in this circuit, two meshes are there. Okay. With the help of mesh analysis, when you want to solve, first of all, identify how many meshes are there. After that, you can represent mesh currents either clockwise or anti-clockwise, your wish. But now, what is the difficulty that you are getting with the, for this question or circuit? Here, one current source is there, which is common for both the meshes, and we don't know voltage across it. We don't know voltage across it. Whenever you are coming across like that, then we will treat superficially one mesh. Accordingly, the name is super mesh. That's all. Okay. Suppose if one voltage source is here or one resistor is here, then you can apply one mesh equation here, one mesh equation here. After that, you can solve. But whenever you are getting such kind of difficulty, like one current source is there, which is common for both the meshes, when you don't have voltage across it, superficially we have to treat as single mesh. Okay, fine. Now, with respect to this branch, you know the voltage. This branch, current I1 is flowing accordingly. Plus sign here, minus sign here. Right? Okay. Next, here in this branch, like as we discussed earlier, here no current flows. That means these two branches are connected. These two resistors are connected in series. Equivalent resistance I am considering directly, just like earlier question. 10 more. Fine. Now, in this entire branch, the current I2 only flowing. I2 only flowing. Correct? Yeah. Now, with respect to this current, here plus sign, here minus sign. Okay. Right. Now we are writing one mesh equation superficially considering these two meshes. That means we are ignoring this current source. Okay. Initially. Okay. So here minus 2 plus 12. Then plus 2 minus. Just use Ohm's law. 6 into I1. Then plus 2 minus 10 into I2. 10 into I2 is equal to 0. Okay. So in this entire equation, you can divide whole equation with 2. Then you are getting 6 minus 3I1. Just to do the calculation simpler. Okay. Minus 5I2 is equal to 0. Whole equation divide with 2. 6 minus 3I1 minus 5I2 equal to 0. Okay. So here we have written one mesh equation by considering these two meshes together. Now, in this equation, two unknowns are there. To find out two unknowns, one equation is not sufficient. We require one more equation because two unknowns. So here you can apply KCL. You can apply KCL at this node or at this node. Anywhere you can apply. Suppose I am applying here. Here current I1 is entering. Here 6 ampere is entering. Here I2 is leaving. Okay. So sum of entering currents equal to sum of leaving currents. So I1 plus 6 is equal to I2. Just have observation. I1 is entering, 6 is entering. Together, I1 plus 6, I2 is leaving. Fine. Here, ultimately, what you require? You require voltage across these two terminals. That means this branch current you require I2. Okay. So just rearrange this equation. See, ultimate agenda is from here you should get I2. Okay. That means just rearrange this equation. I1 equal to I2 minus 6. I1 equal to I2 minus 6. That one you can substitute here. Yeah. So 6 as it is minus 3 into I1. I2 minus 6. Then minus 5I2 is equal to 0. Now do the simplification. 6 as it is, minus 3i2, minus into minus plus, 3 6 are 18, minus 5i2 is equal 0. So minus 3 minus 5, that is minus 8. Bring other side, it will become positive. So from here you are getting 8i2 is equal to 6 plus 18, that is 24. So from here you are getting 4 2s 4 6. Sorry, directly you can do 8 3s are 24. Fine. Yeah, 8 3s are 24. So from here you are getting I2 equal to 3 ampere. I2 equal to 3 ampere. What we require? We require VTH. We require VTH, that is nothing but between the terminals A and B. That voltage is nothing but across 4. Across 4. So 4 into I2. I2 is what? 3. Same answer, 12 volt. VTH equal to 12 volt. Same. Option B is the correct answer. So as of now, we discussed 3 methods from first chapter. With the help of these 3 methods, just give a try. From the first chapter, any other method possible for this question, for finding VTH. Yes, we can apply source transformation as well. Okay, next one, source transformation. Right. So here first step, what we have to do, very simple, just have observation. Here voltage source is connected with in series with resistor. So this is nothing but practical voltage source. Here you can apply source transformation. Okay, you can convert into practical current source. So here what you are getting? One current source you are getting. That current source direction, how we have to represent, either upward or downward, very simple. Once again, just focus. This is a source. Source means current should leave from where? Positive terminal. That means current direction will be upward. That's all. Okay. So now how to get that current value? Just use Ohm's law. 12 divided by 6. Voltage source divided by resistance. 12 by 6, that is nothing but 2 ampere. Right. Now that current source, you have to connect in parallel with that same internal resistance. So here in this case you got 6 ohm. So this is the important note point. Whenever you are applying source transformation, internal resistance will remain same. What you are doing, just to do the calculation simpler, or just in order to get the simplified equivalent circuit, wherever there is a requirement, you can apply source transformation. Okay. So here practical voltage source is there, that one you can convert into practical current source in parallel with resistor. Okay, up to here we got. Now after that, here what you are having, 6 ampere is there, just connect that one, just connect that 6 ampere here. Now just observe. See, we are doing step by step. This part of the circuit equivalent is this one. After that, I connected this 6 ampere. Now, after this, here 6 ohm, 4 ohm is there, that will append. Okay, in some time. Now just observe. Here 2 ampere source and here 6 ampere source. Current directions are same. That means, and here both are connected parallel. Okay, and current directions are same. Now you can add. The result, both the current values, and you can replace as simple one current source. Okay, 2 plus 6 is nothing but what? 8 ampere. So here we are getting 8 ampere source. Okay. Now after that, it is connected in parallel with 6 ohm. Okay, whatever we have done so far, that is the equivalent circuit with respect to the terminals here. Say for example, for the time being, I am labeling this node as C and this bottom node as usual B, because all these points are one the same. Between C and B, whatever circuit is there, that entire circuit, simplified form, we can represent like this. Okay, after that what you're having? After that you're having 6 ohm resistor and then 4 ohm. Six ohm resistor and then 4 ohm. Here you have to find out the VTH. Here you have to find out the VTH, right? Okay, just for reference I am putting same label AB. Okay, now here you can observe once again, as we told multiple times for this question, there is no current flows in that terminal or branch. Okay, so these two are connected in series, so equivalent resistance you are getting 10 ohm. Now earlier we already applied voltage division rule. When elements are connected in series, we can apply voltage division rule. When elements are connected in parallel, we can apply current division rule. See the beauty of the questions that I have collected. Matlab we are discussing in this session, whatever the concepts or formulas or theorems that you learned, with the help of questions, we are applying, and through that you are learning all the recap of all the important concepts and most important concepts, whatever basics are there. And for the given circuit, wherever the corresponding basic law or basic theorem or method or whatever the network theorem or any circuit, how to solve each and every angle dimension that you are getting to know with the help of our YouTube live sessions. Okay, in today's session, tomorrow's session, together you are getting great insights regarding network based subject. Okay, fine. Now just observe 8 ampere current is entering. Here 6 ohm and 10 ohm. How all the elements connected? Parallel only, right? In parallel, you can apply current division rule. So in this branch, suppose I am assuming the current flowing in this branch is like I. Okay, so if you want to find out that I, entering current is 8, okay, into, see voltage division rule means across which branch you want voltage, that branch resistance will come as a numerator. But current division rule means in this branch, if you want the current, opposite branch resistance will come in the numerator, that is 6. Denominator part as usual, sum of all the branch resistances, like 6 plus 10. 6 plus 10. See, here equivalent resistance is 10, so 6 plus 10 is coming in the denominator. Across, through 10 ohm you want to find the current, so opposite branch 6 is coming in the numerator. Fine. So here 8 6 are 48, divided by 6 plus 10 is 16, that means you are getting 3 ampere. Current flowing through this 6 ohm, current flowing through this 4 ohm, or current flowing through this net equivalent resistance 10 ohm, all are one the same. Now you can apply Ohm's law, that's all. That is your VTH. VTH equal to 4 ohm into current is what? 3 ampere. Same 12 volts. Same 12 volts. Here for understanding purpose, I have drawn the equivalent circuit, but part of the analysis you can do in the mind level. After that, directly if you want, you can draw this circuit, or you can do this circuit visualization in the mind, and you can do these steps only on the book or paper you can write. Matlab with respect to gate exam point of view, I am telling. So once again, same answer, that is option. So far we have discussed 4 methods with the help of first chapter, right? Now we are going to discuss with the help of second chapter. With the help of second chapter, whatever the theorems that we can apply, that we are going to do. Okay, so because 2 sources or more than 1 source is there in a given circuit, definitely you can apply superposition theorem. Okay, yeah. So with the help of superposition theorem, we are going to find out VTH, right? So you have to consider 1 source at a time. Because of that, you have to find out the response. Similarly, like that you have to do for every source in the given circuit, how many sources are there, that many times you have to solve the question. Okay, but wherever there is a possibility, say for example, when you're having 2 sources, suppose some question you can easily solve with the help of superposition theorem easily, then you can use that theorem in the gate exam. Okay, but sometimes suppose 3 sources are more than that, if it is present, Then if you feel with the help of superposition theorem it is easy for you, you can do. Otherwise, with the help of first chapter concepts only easy for you, account you can go ahead. Because some questions, like just like we have discussed, like current division rule or voltage division rule or source transmission, etc., with the help of that basic laws or basic concepts, if possibility is there, you can do the calculation part easily, then definitely you can apply superposition. With respect to DC circuits, I'm talking. Regarding AC circuit, definitely when two AC sources are present or one AC source, one DC source, definitely superposition theorem, with the help of that only you can solve the question. Without that, not at all possible. Okay, right. Yeah. So now let us consider one source at a time. So here I am considering 12 volt source. That means 6 ampere source. What we have to do? We have to make it as open. We have to make, just remove the current source. Then in this branch, no current flows. Fine. Case 2, we are considering 6 ampere source. 12 volt source we have to deactivate. Deactivate means here we have to make it as short. Because when you make here short, voltage across this branch will be what? 0 volt. 0 volt means we haven't connected the voltage source, simple. And similarly, current source we should not connect here. That means current source value should be 0. 0 means what? Open circuit. Fine. Now, between these two terminals, voltage we have to consider. Case 1 means VTH1 I am writing. Case 2 means VTH2. VTH2. Okay. Now see the beauty of this circuit. How easily you can solve. Now, just observe. Here no current flows. That means these two are connected in series. Equivalent resistance is 12 ohm. Fine. Now 12 volt source, 12 ohm and 4 ohm. How these three are connected? Series. Series. Yes or no? Now across 4 ohm you want the voltage. You can apply voltage. Voltage division rule. That's all. That's all. So here VTH1 is equal to 12 into 4 divided by 4 plus 12. Or 12 plus 4. In any order you can write, no problem. So 12 4s are 48, divided by 12 plus 4 is 16. That means you are getting 3 volts. 3 volts. Here for understanding purpose, we are using pen and paper you can do. But actually calculation part, if you observe, exactly similar, most of the gate questions will be there. You can do the calculation at mind level. Okay, yes. But whatever the final value you are getting, you can write. But if you require, sir, calculation part also required, 1 or 2 steps, you can know, no problem. Yeah. Now here we have to find out VTH2, that is nothing but across 4 ohm. Okay. Now here if you observe, as we discussed multiple times in this question, open circuit voltage or Thevenin's voltage, that time in this branch no current. In this branch no current. Okay. So you can consider here equivalent resistance. 6 plus 4, that is 10 ohm. 10 ohm. Fine. Now just observe. Here 6 ampere source is there. 6 ohm and 10 ohm. All the 3 elements are connected in parallel. You can apply current division rule. Okay. Accordingly, you can find the current flowing in this particular branch. So I am labeling here, it is I. Okay. So if you observe earlier question, like here we got like 8 ampere, then 6 ohm and then 10 ohm. Okay. Like that similarly you are getting here. Similarly. But here in this case 6 ampere was there. Okay. Right. So in this case the current flowing through 10 ohm resistance is, supply current is 6 into opposite branch, that is 6 divided by 6 plus 10. Right. So from here you are getting 6 into 6 divided by 16. 6 into 6 divided by 16. So 2 3s are 6, 2 8s are 16. Then once again 2 3s are 6, 2 4s are 8. So you are getting 9 by 4. 9 by 4, because it is a current, units are ampere. See, whatever the current we calculated, that is flowing through 6 ohm, that is flowing through same 4 ohm. Or even it is flowing through equivalent resistance 10. Now you want VTH2, that is nothing but voltage across 4 ohm. VTH2 is nothing but 4 into I. I is nothing but 9 by 4. Now 4 is getting cancelled, you are getting 9 volt. 9 volt. Now you can use superposition theorem. That's all. Here voltage you got positive, here also positive. That means resultant voltage you can add. If voltages are, you are getting here positive, there negative, then you have to perform subtraction. Okay. If voltage polarities are different, then subtraction. Okay. If voltage polarities are same, then you can add algebraic sum. Okay, so here 3 volt and there 9 volt. By using superposition theorem, in short I am writing the resultant Thevenin's voltage is nothing but VTH1 plus VTH2. So in case 1 we got 3, case 2 9. 3 plus 9, that is 12 volt. 12 volt. Same. Option B is the correct answer. Option B is the correct answer. So far we have discussed how many methods? 5 methods. 5 methods we have discussed, right? So one more method also we are discussing. Here we have to find out Thevenin's voltage, right? Okay. Yeah, we are using same theorem. Thevenin's equivalent circuit only. Stage by stage we can follow. See, according to overall circuit, you have to find out the Thevenin's voltage. Okay. You can perform stage by stage also. Say for example, whatever this part of circuit you are having. Okay. So initially you can observe this part of circuit, and for this part of circuit you can just find out the Thevenin's equivalent circuit. Thevenin's equivalent circuit means voltage source in series with resistance. Okay. Just you can connect that one. After that you can do further like that. Okay. Now for this part of circuit we have to find out the Thevenin's equivalent circuit. Thevenin's equivalent circuit. Now that part of circuit here I have considered. Part of circuit. Okay. So this part of circuit you can replace like this, VTH in series with RTH. After that, whatever the rest of the circuit you're having, like 6 and 4, yes, that I connected as it is. Okay. Yeah. Now here, like between these two terminals you have to find out the voltage. For the timing here I'm labeling as VTH1. Because overall circuit here I have to find out VTH. Okay. Now, just like earlier, here no current flows. Fine. If no current flows means the 6 ampere whatever is coming, that entire 6 ampere is going like this. Yes sir. Right. Now by using Ohm's law, here 6 into 6, that is 36 volt. Right. Okay. Now here 12 volt. Just you can apply KVL like this or like this, in any direction you can do. No problem at all. Okay. Since so far we have discussed that KVL, even now whatever the method or notation that I am using, that is KVL based only, but without writing equation you can get the final value. Okay. But if you are good at logic, that's all. If you are good at logic and if you are not doing silly mistake, then definitely you will be getting correct answer. But to get that answer you are using KVL only. Okay. Right. So what is our objective? Very simple. Here our objective is between these two terminals we have to find out the voltage. That is your VTH1. Correct. Now in this overall circuit, between these two terminals you want the voltage. Now when you have observed, other side you are having 2 more components. Just you keep the voltages on other side. That's all. Okay. Here 12 volt was there. Here 12 volt was there. I am keeping as it is 12 volt plus minus 12 volt. Right. Now here across 6 ohm voltage was there. Polarities here, whatever you are having, just keep this resistor vertical element. Just keep this resistor vertical element, then you are getting voltage polarities plus minus. See, even if you are having slight confusion, sir, whether I have to write plus minus or minus plus, very simple, just have observation. Here plus sign was there and here minus, right? So minus plus, you keep like that. The moment one polarity, if you are able to keep correctly, automatically other polarity you can keep correct. Okay. So now just observe. Here you got 2 voltages, polarities are same. Yes or no? Plus minus. That means you have to add. Just like earlier when we are having 2 current sources, direction is upward, both are current in parallel, resultant current is what? We have added. Just like that. Like whenever you are applying KVL, if voltage polarities are same, you will be adding. If voltage polarities are different, you will subtract. Okay. Now here voltage polarities are same, you can add. So that means here 36 plus 12, 36 plus 12, that is nothing but 48 volts. Now just observe. Between these two terminals, voltage VTH1. With respect to other part of circuit, exactly between the same terminals, you got voltage 48. That means these two are one and the same. These two are one and the same. So from here, what you are getting, VTH1, you are getting 48 volts. Whoever not able to understand this concept, no issue. You just apply KVL either clockwise or anti-clockwise. Your wish, you'll be getting same value. But same answer in order to get without writing KVL, okay, you follow this approach. But whatever this notation I discussed, that is based on KVL only. But we are not writing the equation, that's all. Okay, now coming to RTH, in order to calculate, what we will be doing with respect to the terminals, okay, open circuit terminals, you have to find out the equivalent resistance. For that here voltage source was there. You will make it as what? Short. Current source means what? Current source means you will make it as open. Voltage source means you will make it as short. Current source means you will make it as open. Open means you remove current source from circuit. Then what you are getting? Between these two terminals, you are getting one single resistance, that is nothing but 6 ohm. Okay. I hope you understood. So that with that understanding, I am writing direct step here. Yeah. So RTH1, we are getting this 6 ohm. Okay, very simple. With respect to open circuit terminals, here voltage source is there, current source is there. Voltage source means short, current source means open. Between these two terminals, only one resistor was there. That is equivalent resistance, 6 ohm. Yes, Suganya, it is very simple. Just write the KVL here. Minus to plus VTH1, then plus to minus minus, plus to minus minus. That means you can add these two. Right. Here minus to plus VTH1. Here plus to minus. That means you are getting minus. Then other side equal to 0. Then VTH1 equal to what? 36 plus 12 only. So very simple. What I have done. Here 12 volt source was there. That I have kept as it is. 12 volt. Okay. Here 6 ohm was there. And by using this current 6 ampere, you are getting voltage plus here minus here 36 volt. This resistance you keep vertical element like this. Then plus you are getting here, minus here you are getting plus minus, same polarities. No, you can add. See, if you are having any doubt, just write in this closed path one KVL. From there also you will be getting same. VTH1 is nothing but 48. After that you can understand this one, like how we are able to write. Is it clear, Suganya? If still any doubt is there, you can mention. Okay, no problem. I will write that equation. Because we discussed good number of questions, that's why I have not written that KVL. Okay, clear? Great. Now here you are getting VTH1. VTH1 we got 48 volt. VTH1 we got 48 volt. Right. RTH1 we got 6 ohm. RTH1 we got 6 ohm. So between these two terminals, say for example, in this circuit, suppose if you are labeling this node as C and the bottom node anyway, it is same only, right? That B only. So between C and B, whatever the part of circuit you got, that entire part of circuit we can replace as simplified equivalent circuit, a voltage source in series with resistance. That's all. That is nothing but Thevenin equivalent circuit or practical voltage source. Right. Now here, like our objective is what? Once again, here voltage across these two terminals, that is actual Thevenin's voltage as per the circuit. Okay, fine. Now, as we discussed, here no current flows. If no current flows, that means here 48 volt, 6 ohm, 6 ohm, 4 ohm. How all the three elements, all the four elements are connected? Four components. Voltage source, 3 resistors. How these 4 components are connected? Series. Because here no current flows, no. Because of this supply, whatever the current is flowing, that current is flowing like this. This is a closed circuit. All the elements are connected in series. In series, current will be same. Voltage getting distributed or voltage getting divided across the each and every resistor. Okay. Now just use voltage division rule. Just use voltage division rule. VTH equal to supply voltage 48. Across 4 ohm you want, that resistance will come numerator. Denominator is sum of the resistors. 6 plus 6 plus 4. So here 48 into 4 divided by 12 plus 4, that is 16. So 16 3 times 3 4s are 12. Yes, exactly same answer, 12 volt. 12 volt, same answer. 12 volt, option D is the correct answer. Yes. So far, whatever we have discussed regarding Thevenin's equivalent voltage with respect to the terminals A and B, with the help of first chapter, we have discussed 4 methods. With the help of second chapter, we have discussed 2 theorems or 2 methods. Superposition we have used, Thevenin's we have used. Similarly, if you want, you can use Norton's also. But for the time being, I am not discussing that method here. Okay. But anyway, with the help of other questions, we will see. Okay. Like that, if you feel any other method or concept or theorem, with the help of first chapter and second chapter, you people can contemplate. If you get any idea, you people, whoever attending currently live session, you can mention the chart. And whoever attending, watching this session the recorded, you people can mention if any other possible method is there. You can just mention the concept name or method name or theorem name, whatever possible in the comment section. Mention the question number and mention the respective method. If that is appropriate for that question, if it is possible, then definitely I will appreciate. But suppose if whatever you are mentioning is wrong, then I will mention also that is not applicable for that question. Okay, no problem. You people are having complete freedom. It's not that whatever I'm discussing, that is the only final. But if you can contemplate, if you are getting further more possible, I will definitely appreciate. But because we are having limited time, whatever the best possible methods are there, I have covered. Because with the help of one question, I want to cover whatever the theorems or concepts that are possible, because this thought process will help you, especially whenever you are solving any question in the GATE exam. If you are having 100% confident about your answer, no need to verify with the help of any other method. But even if 1% self-doubt is there, my answer may be wrong, then you can verify with the help of other possible method, just to make sure that that one I have touched this point. With the help of this one question, we have solved 6 methods, right? 6 methods. Yeah. So now let us calculate the second part of the question, that is RTH. Regarding that, you are having 2 choices, right? Because this question is MSQ. Okay. Now, coming to the calculation of RTH, okay, earlier part of the circuit, I haven't drawn the equivalent circuit, but I have shown, okay. But now with the help of this question, you are getting a better clarity. Okay. See, if you observe starting so many questions, whatever we discussed regarding equivalent resistance, in those circuits, you are having resistances only. Okay. But here currently what you are having sources also in addition to resistors. But whenever voltage source is there, you have to replace as short. Okay. Voltage source is there, you have to replace as short. You have to replace as short circuit. Then if current source is there, you have to replace as open. Then what is happening? In a given circuit, you are having completely resistors, then definitely you can find out R equivalent. That is nothing but RTH, that's all. Okay. Now here, because no current flows here, these two are connected in series. Equivalent resistance is what? 12 ohm. Now, that 12 ohm and 4 ohm, how these two are connected? Parallel. Those two are connected in parallel. So here RTH equal to 12 into 4 divided by 12 plus 4. 12 plus 4 is what? 16. So here 4 times, 4 3 times. That means RTH value you are getting 3 ohm. RTH value you are getting 3 ohm. That is there in option C. So for this question, two correct choices are there. Option B and option C. Option B and option C. Yeah, for this question, finally we got two correct choices. Option B and option C. This is a MSQ question. Okay, two correct choices are there. Yeah, I am showing the next question. All of you can do it. I am giving the timer also. If you want, I am putting more time. If you want, you can take the break also. Yeah, Suganya, regarding RTH, your answer is correct. Regarding VTH, you can cross check once. Regarding RTH, your answer is correct. There is no doubt. Yeah. So in this question, we have to find out both VTH and RTH. Okay. Yeah. So first of all, we have to find out the VTH with respect to the terminals A and B. As we mentioned earlier, open circuit voltage, that means no current flowing in this branch. If no current flows in this branch, by using Ohm's law, 0 into 3 is what? 0. See, whenever you're having any finite resistor or practical resistor, in that branch, somehow that if you got to know current flowing through it is 0, that means by using Ohm's law, you're getting voltage across it is 0. Or in other words, vice versa. Somehow there if you got across that particular resistor voltage 0, by using Ohm's law, you're getting current flowing through that branch as same, 0 only. Okay, fine. Now you understood in this particular circuit, because no current flows here, because of that voltage drop here it is 0, that means across these two terminals voltage is as good as across these two terminals voltage, across these two terminals voltage, because here these terminals contain parallel, and here one branch is there, one component is there in series, but there is no voltage drop. That means here in this question, VTH and Vx both are one the same. That is the first and foremost observation point. In this question, Vx and VTH both are same. Because here no drop. Suganya, is it clear? If you have any doubt, you can mention. Okay, no problem. Yeah. So this is the first observation. Now here 2Vx is there. Here 3 ohm resistor is there. One side voltage is 2Vx, another side voltage is Vx. Okay. By using Ohm's law, here 2Vx minus Vx, that means Vx, that is a voltage drop you are getting across 3 ohm. Here 2Vx and here Vx, that means Vx divided by 3 ohm. In this branch, current flowing is Vx by 3. And here in this branch, current flowing is Vx by 6. And here current flowing is 1 ampere given, and here no current flows. Just apply KCL here. In general, you used to apply nodal, but here if you want, you can write like that also. But to solve the question easy, wherever you can apply Ohm's law, accordingly you can apply. After that, just apply KCL. See, nodal equation is nothing but combination of KCL and Ohm's law. Okay, that's all. Now with this understanding, just apply KCL here. Here current is entering. Okay, Vx by 3 is entering, Vx by 6 and 1 ampere are leaving. So you are getting Vx by 3 is the entering current, only one branch, and whereas in two other branches, currents are leaving. Okay, right. So Vx by 6 and 1 ampere are leaving. Okay, fine. So sum of the leaving currents equal to sum of the entering currents. Now from here, just rearrange. If you bring this term other side, it will become negative. Okay, Vx by 3 you can, okay, I will write one step, after that I will take common, no problem. Vx by 3 minus Vx by 6 is equal to Vx by 3 minus Vx by 6 is equal to 1. So here you can take Vx by 3 as common. If you take Vx by 3 as common, if you take Vx by 3 as common, then what you are getting from first term, Vx by 3 I have to common, so you are getting 1 minus Vx by 3 I took common, that means 1 by 2. Just multiply so that you can cross verify whether it is matching or not. Vx by 3 into 1, yes. Vx by 3 into 1 by 2, Vx by 6, yes, is equal to, on the other side you are having 1. Now from here what you are getting, Vx by 3 into 1 minus half is nothing but 1 by 2 is equal to 1. Now here denominator 3 2s are 6. You can do cross multiplication. From here you are getting Vx equal to 6. Vx equal to 6 volt. As we have mentioned in the starting only, in this circuit Vx and VTH both are one the same. So VTH for this question is going to be same value, 6 volt. VTH equal to 6 volt. Yeah. So 6 volt is there where? Option C. Option C. Okay. Right. For this question, VTH value is 6 volt. I hope it is clear now, Suganya. Yeah. Coming to the calculation of RTH. You can solve in two methods. Okay. You can solve in two methods. So for the timing, since we already got VTH here, let us calculate the short circuit current, how much it is flowing. After that, you just use Ohm's law. From there, you are getting RTH. Okay. So since we calculate VTH now, let us calculate short circuit current. Short circuit current or Norton's current, both are one the same. Short circuit current or Norton's current, both are one the same. Open circuit voltage or Thevenin's equivalent voltage, one and the same. Like that, short circuit current or Norton's current, both are one the same. See, simple logic. Whenever if you keep terminals open, no current flows there, but voltage you are getting. Similarly, whenever you are shorting terminals, voltage across it is 0, but current will flow. Okay. So if you want to find the current, closed path should be there. That's why we are making shorting. And if you want to find the voltage, you have to keep terminals open. That's all. Fine. Now in this case, we have to find out short circuit current, right? Now here in this question, if you observe, okay, so the bottom node, generally we used to consider as a reference ground, okay, and in this case, this node voltage with respect to ground is Vx, because based on the question, like across 6 ohm voltage Vx, that node voltage I have represented. This node voltage with respect to ground, okay. So regarding this branch current, we already calculated 2Vx minus Vx, that is Vx divided by 3. We already calculated in the earlier question, exactly same. Now, in this branch also, we already calculated, that is Vx by 6. Vx by 6. And here 1 ampere is leaving. Earlier question, what happened? Here terminals are open, no current is flowing. Okay. But here terminals are shorted, definitely current will flow. And between this point and this point, okay, 3 ohm is there, just like this 6 ohm, correct? Here 6 ohm, 1 ampere and 3 ohm, all are contained parallel. Okay, just like here you have used Ohm's law, like that you can use, here you are getting Vx by 3. Vx by 3. Now, very simple. See, these two nodes are one and the same only. These two nodes are one and the same, because between these two nodes there is no component, only one wire is there, right? So, just like here bottom node is same, like that here these two nodes are one and the same. Now, to this particular node, branches wise, just have a count. 1 branch, 2nd branch, 3rd branch and 4th branch. 4 branches are connected. Okay. Sum of leaving currents equal to sum of entering currents. Now, if you closely observe here, here Vx by 3 is entering, Vx by 3 is leaving. See, overall for this particular node, see either here or here you can count, no problem. So, this one principal node to this particular principal node, Vx by 3 is entering, Vx by 3 is leaving. Balanced? Fine. Here Vx by 6 is leaving, here 1 ampere is leaving. Okay. So sum of all the leaving currents equal to what? 0. Okay. Right. So see, I am not writing the entire equation because I am assuming that by this time, because we have solved good number of questions right from the beginning, we have discussed each and every question, like whatever the equation. So now I am assuming that you have reached your understanding level higher side. So if you want, you can write the equation, but just to save the time, I am not writing complete equation, but just for reference, I have put double tick here. See, to this particular node, Vx by 3 is entering, Vx by 3 is leaving. It is balanced. Here, 2 more branches are there. In both the branches, currents are leaving. Okay. So, sum of leaving currents equal to 0. That's all. That is your case here. So, here Vx by 6 plus 1 is equal to 0. From here, if you rearrange this equation, Vx by 6 equal to minus 1. From here, Vx equal to minus 6. Vx you are getting minus 6 volt. Vx you are getting minus 6 volt. Fine. Okay. Vx you are getting minus 6 volt. Now what is your objective? Short circuit current? Yes, you can use Ohm's law. So here short circuit current or Norton's current, both are one and the same. That is nothing but in this example, the current flowing through 3 mho, and that is nothing but here Vx by 3, Vx by 3, and Vx value just now we got minus 6. Just substitute here, minus 6 divided by 3, that is nothing but minus 2 ampere, minus 2 ampere, right? Okay, in this particular question, short circuit current between A and B, you are getting minus 2 ampere. So that means what it indicates, between B and A means current is positive, 2 ampere. Actually, current is flowing 2 ampere like this, because in this circuit between A and B, so current should be downward, so that current you are getting negative. Okay, minus 2 ampere. So earlier VTH you got 6 volt, now short circuit current you got minus 2 ampere. Now you can use Ohm's law, that's all. So RTH equal to voltage divided by current, VTH divided by short circuit current. So VTH we got 6 volt, and short circuit current we got minus 2. From here you are getting minus 3 ohms. See, in general, whenever in the given circuit, if only resistors are there, definitely you will be getting resistance value positive, equivalent resistance. And similarly, whatever earlier some questions we have discussed, like when voltage source, current source, like whatever, like these sources when you are having, say for example, yeah, just like this, whatever ideal sources or independent sources when you are having, then also you will be getting equivalent resistance as what? Equivalent resistance as you are getting positive only. But whenever in the given question, if dependent sources are present along with independent source are not, in some questions, like along with resistors, when dependent sources are present, for some of the questions there you will be getting negative also. For some question you may get positive also, but some questions equivalent resistance you may get negative. With respect to this chapter, especially I am talking about Thevenin's equivalent resistance or Norton's equivalent resistance. Similarly, in the two-port network also, regarding any particular parameter, even though the parameter value is impedance or admittance, still there are chances with respect to this concept and with respect to two-port network, some parameters you may get negative. Suppose if you are getting negative, you have to choose that option only. If the question is NIT, you have to mention that sign also. But except these two places, remaining all the cases, definitely you will be getting positive. There is no doubt in it. Okay. But how to justify with respect to interview point of view? Practically, negative resistance is not possible. But when we are calculating equivalent resistance, when you are getting negative, what it indicates? Very simple. That part of the circuit, actually it is acting as a source, not as a passive element. That is the indication. Because for the source, internal resistance you will be getting negative. Because whatever practical resistance you are having, like 6 ohm, 3 ohm, etc., all the values are positive, either in the order of ohm or kilo ohm or mega ohm, etc. You never went to any shop and asked that give me minus 5 kilo ohm resistor. Not at all possible. Whatever the practical resistors, inductor, capacitors values are there, positive only. But in the circuit, in order to represent, whenever you are getting negative resistance, that means the part of circuit is acting actually as a source. That is the indication. Okay, fine. Yeah. So we solve this question by using VTH and then short circuit current. This is one approach. And whenever you are having circuit, in order to calculate RTH, especially if you are having like in the given circuit along with resistors, if independent sources and dependent sources are present, or even only dependent sources are present, if you want to solve the RTH calculation easily in less time, you can use test source method. See, but only one precaution. If only, like say for example, if only dependent sources are present along with resistors, then definitely you can connect the test source externally from your side between the terminals A and B. But so that time you can easily solve. But many of the students will do one big mistake when you are having independent source also, but because of this dependent source, they want to solve the question by using test source method, because with the help of test source method we can get the answer quickly. But only one precaution, if at all if you want to connect test source, very simple. When we are allowed to connect test source, very simple, in the given circuit, if there is no independent source, then only we are allowed to connect test source. Like whenever you are having along with resistors one few dependent sources, either single or multiple dependent sources are there. Because voltage source or current source, whenever independent sources are there, we are able to replace with its internal ideal case resistances. But dependent source, we don't know internal resistance value. That's why we used to connect externally test source. Okay, that test source can be voltage source or test source can be current source. Okay, but if at all, if you want to solve like this circuit questions also with the help of test source method, you have to apply just like in this circuit. If this dependent source is not there, just like earlier question, just like earlier question, whatever the first step you have done in order to find out RTH, exactly same step if you apply, voltage source will become short, current source will become open. Now part of circuit you are having what? Resistors. Now in this case, what you'll be having? This current source you will make it as open. Now you are having resistors, and along with that dependent source is there. Now you are allowed to connect test source. That is the only precaution. If you are very much alert, then definitely you can solve the question in less time. But whoever having like, sir, I may forget this point, then better you can solve whatever the approach we have discussed, VTH and short circuit current, and then you can use Ohm's law. Okay, but somehow other, if you practice good number of questions, then definitely you can overcome whatever generally many of the students will forget that point while applying test source method, that you can overcome. Okay, yeah. So now with this understanding, now we are solving in order to find out RTH, we are using test source method. Okay, so here 1 ampere source was there, current source, we are replacing as open circuit. That is the first step. Okay, now after that resistors are there, dependent source is there. Okay, now you can connect one test source. Now which source we have to connect? You are having complete freedom, but if you want to solve the question easy, very simple, just have an observation. Suppose if you connect 1 volt source here, because of that directly are you able to get across this 3 ohm how much voltage you are getting, or how much current is flowing through this 3 ohm? Not possible. But in this case, suppose if you connect 1 ampere source, if you connect, then because of that through this 3 ohm, you know the current, because now these two elements connected how? Series. In series, same current is flowing, 1 ampere, and by using Ohm's law you are getting voltage. So with respect to this, whatever the element here present, with respect to which source you are getting current or voltage with respect to that other element, then accordingly you can connect that source. Okay, suppose example, the same 3 ohm is connected here parallel. Now in parallel you can connect voltage source, because in parallel voltage will be same, and accordingly by using Ohm's law you can find the branch current. That's all. Okay, now here with respect to this 1 ampere source, we have to find out the voltage. Suppose I am labeling here voltage as V1, suppose V1A or V1, whatever. Because it is a source, accordingly I have kept the polarities, because when you are saying source, current should leave from positive. Okay, right. Now here 1 ampere and 3 volt you got, right. Next, here we already discussed 2Vx is there and here Vx, and by using Ohm's law, here Vx by 3 is going, and here already you know that is Vx by 6. Yeah, that much. Yeah, here we want V1. Okay, so here in this branch the current leaving is Vx by 6, and here because no current flows here, so whatever 1 ampere is there, the same 1 ampere is coming like this. Now just apply KCL here, so that you are getting Vx. Yeah, so here Vx by 3 is entering, 1 ampere also entering, so sum of entering currents Vx by 3 and 1 entering, and Vx by 6 is leaving. So just here in this equation, bring this term here, it will become negative. So direct step I am writing Vx by 3, if you take common, then you are getting 1 minus half is equal to 1. If you bring other side, it will become negative minus 1. So from here 1 minus half is half into here Vx by 3, that means Vx by 6 is equal to minus 1, because we already solved similar steps earlier. That's why I have written direct step. See, I already done similar steps here. Okay, yeah. So here Vx by 6 equal to minus 1. From here you are getting Vx value as minus 6. minus 6 volt you are getting. Okay, now here you can apply KVL, because what is our objective? You connected one current source, that means you know the current value. If you know voltage across that, after that you can use Ohm's law. Okay. Yeah, just observe here. See, if you want, you can write KVL either clockwise or anti-clockwise in this closed path. And once again, whatever the notation wise I discussed earlier in one question, same notation I am covering here. Whoever might have faced earlier some difficulty, at least you can just cross check. If you are able to understand that notation wise here correctly, that means definitely you will feel this is the easiest approach. Wherever KVL is required, you can apply this kind of approach, whatever I am discussing currently. We already covered this one earlier also. Now just observe here, we want between A and B voltage. Okay, between A and B voltage we want, that is nothing but plus minus V1. This is the objective, right? That V1 I have written. Now another side if you observe, between the terminals A and B, here you are having voltage how much? Vx. Here you are having voltage Vx, right? Okay. Across 6 ohm voltage is Vx. Fine. Now this 3 ohm resistor, keep vertical element, then you are getting voltage how much? Polarities plus minus 3. See, I am repeating once again. Here voltage polarity plus minus Vx. Now this 3 ohm resistor, keep vertical element, then voltage polarities you are getting plus minus. Now just observe voltage polarity plus minus. Okay, plus here and then minus here. That means you can add. That's all. So from here you are getting resultant voltage plus minus. You can add both 3 plus Vx or Vx plus 3. In any order you can write. Now here very simple. Between A and B, with respect to this branch you are having voltage V1. With respect to this overall branch you got net voltage 3 plus Vx. Suganya, I hope it is clear now. Okay. Yeah. So here V1 we got 3 plus Vx. And Vx value just now we got minus 6. Right. Just substitute here. 3 plus of minus 6 is nothing but minus 3 volt. Yes. You know the current. You know just now you got the voltage. Just use Ohm's law. That's all. Just use Ohm's law. Voltage equal to current into resistance. Okay. Voltage value we got minus 3. Current value we have assumed 1 ampere into RTH. So from here you are getting RTH value as minus 3. RTH or RN, both are one and the same. Norton's equivalent resistance or Thevenin's equivalent resistance, both are one and the same. Yes, very good, Suganya. Very good. So RTH, whatever we got earlier, exactly same answer, minus 3 ohm. So very simple regarding Thevenin's equivalent resistance calculation. Whatever circuits you are having based on the sources, we can make into 3 types. All the sources are of independent type. Then we solved already question. We have replaced voltage source with short, current source means open. But whenever you are having combination of independent and dependent, that time if you want to solve VTH and then short circuit current, after that you can use Ohm's law. That is one method. And other method is what? Test source method. But if you want to connect test source, first step of case 1, we have to apply that one. Then you are bringing the circuit into case 3. Case 3 means along with resistors you are having dependent source only. That time only, because as the name implies, it is depending, right? But because in this circuit no independent source, that's why we have to connect externally one source from our side. Because we are connecting externally, that is the reason we mentioned that wording is test source, but that source can be voltage source or can be current source. Okay, right. So for this question, 2 correct choices are there. So VTH value we got earlier 6 volt. VTH we got 6 volt. RTH we got minus 3. Yeah, 6 volt and minus 3. That means option C and option D are correct. Option C, option D, both are correct. Regarding VTH, 2 choices. Regarding RTH, 2 choices. 6 volt and minus 3. Yes. Next question, question number 11. Yeah, here in this question, Norton's equivalent current. Norton's equivalent current or short circuit current, both are one and the same. Okay, with respect to the terminals A and B. With respect to the terminals A and B. So you have to short the terminals A and B and then find the current. So here you can short the terminals A and B, then you are getting short circuit current or Norton's current. Yeah. So here just observe, the moment you have shorted terminals A and B, voltage across A and B is how much? 0 volt. Voltage across terminals A and B is 0 volt. We already discussed this point. Now, by using Ohm's law, across 2K you are having voltage 0, and by using Ohm's law, 0 divided by 2K, that is nothing but 0 ampere. 0 ampere. No current flows. Okay. Now, see, in general, we'll consider bottom node as a reference or ground. Okay, in this case, between A and B, across A and B voltage is 0. And in general, bottom node when you consider as a reference or ground, and because this ground came here, and here this point also become ground only. This point also become ground only. Right? So that means very simple. Here you're having 2K. Across 2K, you're having voltage as 30 volt. 30 volt. Yeah, Suganya, you can cross check once. Here, across this 2K, one side voltage is 30. See, very simple. Just like here. Say for example, this terminal I am labeling as C. Okay, and this bottom terminal already B was there. Okay. So between C and B, voltage is how much? 30 volt. With respect to this branch. And here, another branch, what you are having? B and A, one and the same. Correct? So here A, B, one and the same in this question. So that means between C and B, you are having 2K. How these two are connected? Parallel, in parallel, voltage will be same. That means this 30 volt you are getting across here. Now by using Ohm's law, 30 divided by 2K, that means 15 milliampere you are getting. 30 divided by 2K, 30 divided by 2K, that is nothing but 15 milliampere. 15 milliampere. Now just observe, to this particular node, here 15 milliampere is entering, and here 10 milliampere is entering. Together 25 milliampere is entering. Here no current flows. Whatever the net current is coming, the entire net current will go here. That's all. So here in this case, Norton's current or short circuit current you are getting 15 milli plus 15 milliampere plus 10 milliampere. That is nothing but 25 milliampere. 25 milliampere. Yes, I hope it is clear now. Now the next question, question number 12. Question number 12. So in the circuit shown, what value of RL maximizes the power delivered to RL? See, in this circuit you are having one load resistor RL. Across that you should get the maximum power. In order to get maximum power across it, what should be the RL? Very simple. RL should be equal to RTH. That's all. That means here you have to remove the load resistor from circuit and then find the equivalent resistance. Okay, Thevenin's equivalent resistance. So here first of all you are removing the load resistor from circuit. Then across the open circuit terminals you have to find out the RTH. And here, just like earlier, if you observe, independent source is there, dependent source is there. If you want to solve by using test source, first of all, independent voltage source you have to make it as short. Independent voltage source was there, so that one you have to replace as short. Okay, independent voltage source if you make it as short. Okay, After that, you are having circuit along with resistors, dependent source. Now you can connect the test source. Now you can connect the test source. So here, which test source we have to connect? Voltage source or current source? Very simple. If you connect current source here, because of that you cannot get here current or voltage directly. But if you connect voltage source, definitely you can get both current and voltage here. So here I am connecting 1 volt source, because just observe, the moment you connected 1 volt source here, across with respect to that source, here this 2K exactly connected in parallel, right? So that means here you are getting plus minus 1 volt like this. Okay, and here as per the given question, plus minus, here as per this polarities that we have considered, account you are getting minus plus, because plus minus opposite. So from here we are getting Vx equal to minus 1 volt. Vx we are getting minus 1 volt. This is the first observation. Suppose if you have connected minus and plus, then Vx will be 1 volt only. But here, with respect to open circuit terminals, with respect to source, we always connect plus here, minus here, right? Like that, when you connected here, polarities become opposite. That's why you are getting negative sign. That means here, minus 1 when you substitute here, minus 1 when you substitute here, so you are getting 2 into minus 1, that is nothing but minus 2 volt, minus 2 volt, minus 2 volt. Okay, right. Now here in this branch, we have to find out the current. Just like earlier what we have done, we have connected one test source. We connected one test source, that is current source. With respect to that source, we calculate the voltage. Now in this example, we have connected one test source, that is a voltage source. With respect to that source, we have to find out the current. Okay, fine. Now here, just if you observe, like with respect to this 1 volt source, based on the polarity plus here, minus here, the current here in this branch flowing is 1 divided by 2K. Okay, the current flowing in this branch is 1 divided by 2K. 1 divided by 2K. 1 by 2 is 0.5. 1 by K we can write as milli. So 0.5 milliampere is flowing like this. Okay, next. Here you are having 1 volt. This node voltage is 1 volt with respect to ground. This node voltage is 1 with respect to ground. Now, with respect to this 1K, one side you are having 1 volt source, another side you are having minus 2 volt. Okay, just use Ohm's law. Here in this branch, how much current is flowing? In this branch, how much current is flowing? This side voltage is 1, this side voltage is minus 2. 1 minus of minus 2 divided by 1K. So from here, how much you are getting? Numerator is 3, denominator kilo is there. Numerator if you bring, it will come milli. So here what is your understanding? Here 3 milliampere is leaving from this node. Here 0.5 milliampere is leaving. That means very simple, to this particular principal node, 3 branches are connected, among which in 2 branches currents are leaving. 3 plus 0.5 together 3.5. That means that 3.5 milli, if it enter here, resultant current 3.5 milliampere can leave in other 2 branches together, right? So with this understanding, we are getting here I equal to 3.5 milliampere. I equal to 3.5 milliampere. Just if you apply KCL. Okay, now you can use Ohm's law. That's all. Voltage equal to current into resistance. Okay, so voltage value we have assumed 1, current value we got 3.5 milli into RTH. So just rearrange this equation, you will be getting RTH equal to 1 divided by 3.5 milli. Okay, so this one you can write it as 10 by 35. 1 by milli you can write it as kilo. Kilo you can write it as 1000. Okay, kilo you can write it as 1000. Now you can do the simplification. So here 5 7 times, 5 2 times, 2000 by 7 you are getting. All of you give it a try. 2000 divided by 7. you will be getting 285.714. 285.714 ohms you are getting. If you want to make it approximation, you will be getting 285.71. If you want to round off to 2 decimal places. Yeah, very good, Suganya. Whatever 2 by 7 you are getting, after that units will be kilo ohm. But here I want to represent in the order of ohm, because here I not mention anything. Complete freedom you are having. Okay, but suppose if you are having choices, or if you are having answer as NIT type, and if order of units mentioned, then accordingly you have to rearrange. But for this question, you are having complete freedom. You can represent in the order of kilo ohm. In the order of kilo ohm means 2 by 7 kilo ohm. Okay, that 2 by 7 you can convert it to normal if you want. Otherwise, if you want to represent in normal order of ohm means kilo, I have written as 1000. Yes, 285.71 ohm. Or if you want to round off to the next integer, then 286 also. Okay, for this question you are having complete freedom, because I haven't put any restriction in the question. Okay. Yes, so coming to maximum power transfer theorem, name wise it is there, but actually it is not a theorem. It is one special case of your Thevenin sequence circuit. Just like you used to calculate current or voltage, similarly across a load you want to calculate the maximum power. Okay, the derived condition was what? RL equal to RTH, provided if the load is variable, and across the load you want to get maximum power. But how to identify whether the load is variable or not? In question they may specify, or in the circuit they can give like this arrow symbol. In some question they may represent like this arrow symbol. That means the resistance value is variable. Or in some question they may represent just like RL or R. That means that value is what? Not fixed. Say for example 1K, 2K, that means values are fixed. But here R or RL, that means value is variable, unknown, right? So in this way you can easily identify whether the load is variable or not. Okay, now the most interesting question regarding maximum power transfer theorem. All of you give it a try. All of you give a try for this question. I am giving time for everyone. Yeah, Suganya, in this question, what is the main important keyword? In this question, if you observe, they have mentioned that the load is having, whatever the load here they have mentioned, it is having resistance of 4 ohm. That means whether the load is variable or fixed in this question. Here load is a fixed. Okay, here load resistance is a fixed value. Now what they are asking, they mentioned that you have to get maximum power across that particular load only. Maximum power across the 4 ohm. Now see the beauty here. Earlier question, the load is variable, and across the variable load you should get maximum power. Okay, but here the question is, load resistor is fixed. Across that you have to get maximum power. But here surprisingly, instead of varying the load, in the part of circuit, some resistance they are varying. Now, that resistance value they are asking in such a manner, you should get maximum power across the load. Yeah, this is the twist in this question. Generally, many of the students have one misconception that, like suppose that logic is okay with respect to any other subject, but the same logic, if they want to apply in network theory, that logic will fail. Say, for example, when you are saying y equal to x, that means x equal to y. That is true. But condition is what? Earlier, like whatever the derived equation that you got, RL equal to RTH, when the load is variable, that means in the part of the derivation, when you have done the derivation for maximum or minimum, first order differentiation equal to 0, that time you have considered variable as RL. Okay. The same logic they will apply. Even the load is fixed because RL equal to RTH is the derived one. So they will apply the same condition here also. That 4 ohm should be equal to here RTH. No, we should not apply. We should not apply. The logic will fail. That's what I'm telling. So here very simple. Let us consider whatever this internal resistance you got. Somehow there. Suppose example, one equivalent resistance you got RTH suppose. Suppose example, just for understanding. Suppose if this load is not there, if you have removed this load, then after that when you calculated equivalent resistance as RTH, then after that what you are doing, like if you want to find current flow into this load, you will be connecting now load. Okay, now supply voltage divided by R, this resistance plus this resistance. Okay, so here what is happening, like yeah, just I'm telling very simple, like say for example this part of circuit you're having VTH in series with RTH. Okay, just for easy understanding I'm writing here. Suppose if you're having VTH in series with RTH, but suppose here RTH is variable, example. Okay, now RL is fixed. Here in this question, VTH, RL are constant, RTH is variable. Okay, if you want to get maximum power across the load, so the formula is what? Power equal to I square into R. Since elements are continuous series, current will be same. So in this branch, the current flowing is I. Okay, so power formula is what? I across the load, power equal to I square into RL. Now I is nothing but VTH divided by sum of the resistances, VTH by RTH plus RL whole square into RL. Now in this whole equation, RL is constant, VTH is constant. RL, VTH are constant. What is the variable? RTH. That means what is your understanding? If current, see RL anyway constant, that means if current value is maximum, because of that you can get power as maximum. If you want to get power as current as maximum, VTH anyway constant, RL anyway constant. See, VTH constant, RL constant. What is variable? RTH variable. Now if you want to get current value maximum, RTH value should be what? Minimum. Yes or no? Or denominator, see, somehow or other, if you make 0 here, then only you are getting maximum current. If 0 is not possible, then whatever the minimum possible here minimum, for that you are getting maximum current. Right? This is the observation point. Whenever the load is fixed, some other part of the circuit resistance is variable, that time very simple, you have to find out the current flowing through the circuit is maximum, that means power across that particular fixed load will be maximum, right? So here the conclusion point is I should be maximum. So in order to make I value maximum, RTH value should be minimum. Okay, now with this understanding, you can do trial and error. See, if you want, you can find out like that in your free time. If you want, you can do like that. But if you want to solve the question less time easily, you just give it a try case by case, because you are having choices, right? Let us consider here in this case R value is 0. Now what happened? 6 and 0, how they are connected? Parallel, equivalent resistance, how much you are getting? 0. Now 2 ohm, 0 ohm connected in what? Series, equivalent resistance will be what? 2 ohm only. Now, in this particular circuit, how much current is flowing? I equal to 12 divided by 2 plus 4. 2 plus 4. That means 12 divided by 6. 12 divided by 6, that is nothing but 2 ampere. Now, after that, you can use power formula I square into RL. Okay, right. Now, just observe. Suppose extreme case I am considering. 0 I have considered. Now, let us consider infinity. Suppose infinity if you consider, then what will happen? Suppose infinity if you consider, equivalent resistance is how much? 6 ohm parallel with infinity. What is the equivalent resistance? This is a very, very interesting question. All of you can give it a try. 6 ohm parallel with infinity. What is the equivalent resistance? No, infinity only. What is the formula? 1 by R equivalent equal to what? 1 by R1 plus 1 by R2. 1 by 6 plus 1 by infinity. 1 by infinity is what? 0. Then 1 by R equivalent is what? 1 by 6. R equivalent is 6. Now, when you are getting here 6, 2 plus 6 plus 4. That means current value is decreasing or increasing? Yes, decreasing. So that means if you want to get maximum current possibility is there. Maximum current possibility is there only when you considered among the 4 choices the minimum possible resistance here. Minimum possible resistance. See that you may not know initially, but you can do trial and error. That's all. Okay, I have shown 2 extreme cases, and similarly if you want 3 ohm, 6 ohm, accordingly some equivalent resistance you are getting. When you are getting that one, you are adding in the denominator. When you are adding denominator term value, if it is increasing, that means overall value is getting somewhat decreasing when compared to here. So that is the indication here. In this case, option A is the correct answer. Okay, this is a very, very important conclusion point. When the load is fixed across the fixed load resistance, if you want to get maximum power, current flowing through that load should be maximum. In order to get like that, whatever the internal resistance of the source, that should be as minimum as possible. Whenever you're having choices, among those choices, with the help of whichever resistor you are getting minimum internal resistance, accordingly that will be the correct one. Okay, so with this we have completed the first chapter and second chapter, all the variety of questions and whichever important and most important concepts are there, and variety of the questions with respect to your coming GATE exam, that we have covered. Okay, right. So coming to 2-port networks, currently I am not discussing, but the questions will be there in this particular PDF. Our team will share this PDF either today or tomorrow morning in our Telegram channel. Okay, whoever having time, tomorrow you can give a try before you are joining the live session. Okay, so I thought to discuss these questions in today's session only, but I have seen your active participation in this session. That is the reason I have discussed in detail regarding first 2 chapters. Okay, no hurry. Tomorrow we are having, just like today, 3-hour session. So regarding 2-port networks, I will be showing some glimpse whatever the questions are there. Okay, you people can give a try. Okay, regarding these questions. Yeah. Okay, I'm just showing the questions. So whoever want to give a try today only, no problem. At least I'm just showing the questions. You people can take the screenshots later. Okay, later, and accordingly you can give a try. Fine. This is a question number 14. Then this is a question number 15. We are not solving the questions now, but I'm giving as a homework because I have seen active participation. Definitely, whoever having time, they can give a try till before you are joining tomorrow's session at 5 o'clock. Yeah, next question, 16th. Yeah, thank you, Shiva, for attending the session. Share this link with your friends also, so that they also will get benefited. Yeah, next question regarding ABCD parameters. Question number 17. Yeah, this is the last question regarding 2-port networks. Question number 18. Here you have to find out the H parameters. Yeah, I have shown all the questions. So definitely every student, whoever attending live or whoever might be watching this session recorded, still you are having buffer time. You people can give a try. Okay. Yeah. So I have planned total 18 questions in this session, but we have completed 13 questions whatever 5 questions are there regarding two-port networks, easily we can solve in less time, but whoever having time, they can give a try. But whoever don't have time, no issue, we will be discussing in the live session tomorrow. Okay, after this we will be covering whatever the remaining 2 chapters are there, transient analysis and then steady state analysis. Okay, we'll be discussing variety of questions from those chapters in tomorrow's session. So just like earlier, whoever attended my digital classes regarding gate score booster in the last class last week, Thursday, Friday, I hope whoever attended live classes and whoever able to get most of the questions correctly, I have appreciated. So exactly same here also, I'm saying that one. Hearty congratulations for all the students whoever attended this live session and whoever able to get most of the questions correctly. Yeah, Suganya, hearty congratulations from my side. Yeah, and whoever watching this session the recorded form and while solving the questions of this session, whoever getting most of the questions correctly, from my side in advance I am telling hearty congratulations for those students as well. Okay, right. Yeah, if you are having any queries, you can mention in the chat. I will be responding in some time. Okay, so just like in earlier sessions, I used to give the important updates. So once again, I'm giving here. Whoever not yet enrolled for any of our programs at our IMS Gate Academy, but if your target gate exam is 2026, you people can enroll for our Tersis Plus program. So you are getting maximum benefits with the help of our Tersis Plus program, because whatever you might have learned or whatever you might have practiced, unless otherwise you got exposure to the test environment, you won't get enough confidence if you want to make, if you want to get best result in the gate exam. Okay, so for that you are getting 2 great opportunities, I can say, with the help of our test series platform and with the help of our PYQ booklet series. Okay, so with the help of these two with the help of these 2 great resources, you can do whatever time available, you can best utilize. You can focus on easy and moderate questions from these PYQ booklets, whichever possible, and based on the time availability, you can solve respective chapters test you can attempt, and respective subjects you can attempt basic subject test. That much is more than sufficient. After that, directly you can attempt full length mock test, whatever possible based on your available time. Okay, so with the help of these tests and with the help of previous year gate questions practice, you can check your confidence and knowledge. And definitely, just like in this party session, in the span of 3 hours, we have discussed number of questions by 13, but number of methods in the network theory subject generally I used to cover more. With respect that, if you see overall count wise, more only. Okay, right, fine. Yeah, so these are the toppers with respect to gate 24 exam at our IMS Gate Academy, and these are the toppers with respect to gate 25 exam at our IMS Gate Academy. Yeah, whoever targeting for gate 26, somehow other, some students might have prepared well or whatever, somehow or other in the last year, but not able to get as per expected result, but still you are giving gate 26 as your, you want to give your 100% best. I am strongly recommending you people, if you can, if you want to best utilize, if you can devote more number of hours per day, daily basis, I am strongly recommending for SLP program. Okay, and whoever targeting for next year, okay, then you people, based on your convenience, whichever program is suitable, accordingly you can enroll. And if you want to get complete details regarding any of these programs, you can book the free counseling session. The link is provided in the description of this particular video. Our education advisors will be discussing complete details. After that, accordingly you can take the call, whichever program is best suitable for you. Okay, yeah, as I mentioned earlier, regarding our Telegram channel, link is provided in the description. So in this particular Telegram channel, whatever this session, during this session or earlier sessions also regarding gate score booster digital 2 sessions, and regarding network theory today and tomorrow, right? After the session over, either that same day or next day, we will be sharing the PDF. Okay, already regarding digital I have shared the PDFs. Regarding network theory, tomorrow I will be sharing. Okay, today's session PDF I will be sharing in this group, in our Telegram channel we will be sharing. Okay, whoever not yet joined, you can join. Okay, yeah, keep learning and keep growing. Try and fail, but don't fail to try. I hope many of you got to know, like during the class today live session, even the some of the students used to get wrong answer or might be doing mistake. Why I have appreciated. See, this is the quote. This quote already some of you already seen earlier in my lectures. So you always can inspire from here. Try and fail, but don't fail to try. Okay, yeah. So as I mentioned earlier, tomorrow we are having second session regarding network theory subject. So in that session, we will be discussing two-port network questions, transient analysis, and not but not the least, steady state analysis of AC circuit questions as well. Okay. So with that, we will be completing regarding network theories subject gate score booster sessions. Okay. Okay. We'll meet you all and tomorrow at sharply at 5 p.m. Okay. Thank you. Thank you everyone.